All right. Man, you know, jumping in with a question like immediately. I don't even have my microphone on. How am I supposed to relay any information? How's it going, everybody? I gotta do some work this Saturday. We got work to do. I had pho before stream, and it got me coughing. So I've just been through a fit of just like expelling everything in my sinuses. Feels kind of good. I feel like I've got a lot of space for a lot of room for activities up there now. Whew. But yeah, I was like a snotty mess a minute ago. Just the bathroom sink. Not a bag of Milky Ways. Thank you so much for the 19 months. Hey, I appreciate that, man. And I don't know. I'm starting to believe that maybe you're not just a bag of sentient candy. Although, you know, we can't be sure about that. Jury's out. Hermit's so hard. Building a drone, any tips on soldering super small contacts? Right tool for the right job. Do you have a soldering iron, what you can replace the tips on? That would be an important start. Otherwise, a pencil-tipped, I want to say pencil dick. No, a pencil-tipped soldering iron of varying dubious quality should be all right. If you don't have something like that, you know, lots of flux. I may be a preacher in the church of the non-flux, but lots of flux helps. I've not been watching games done quick. I haven't gotten around to it. I haven't had any kind of like an incentive to watch. Usually Octoj will link me to a couple things and I'll check one or two out. But no, I haven't actually watched a lot of it. I wasn't even vaguely aware that it was going on until yesterday. Guys, I have been to the negligence of my actual IRL social life. Been working on this. Yeah, I've been head down. I've been trying to finish a project for once. It's just like a work time crunch, you know. Yeah, but if your goal is to solder like small contacts on like a drone, I'm not gonna tell somebody to go out and practice. Yeah, the Electron. You can look it up. I mean, it's like giant text, right? It's bigger than chat. This is my buddy Julian. I'm gonna try to get him in here. He's gone this week. Maybe next week we can get him in. He wants to build like a patch bay. Looks like he has patch bays. Like, wait, you already have patch bays. What do you got me for? I'm gonna cough. Hold on. Oh man. Now, we built Jules that Norn. Apparently he doesn't use it that much. That Norn could practically just make my entire intro music stream. What we're gonna do today, and I'll of course re-explain this, is we need to put a test header on the board over here for the wheel so that I have access to the serial signals going in and out, and so that I have access to the LIN bus stuff going in and out. And that way, it'll be much easier for me to hook it up to the scope. Because remember, the last time I hooked it up to the scope, I think I almost blew up a wire because it made contact to the 48 volt thing. But yeah, add a test header, and that way we can plug the scope in. We can do some test prints on the LIN bus stuff, and I can figure out what the hell's going on with this thing. Because the LIN bus we had pretty much on lockdown. We had that ready to go. So something else is happening in the system that's causing it to be flaky and slow. Now, if it's just gonna be slow, I don't know what I can do about that. I don't know what I can do about it being slow. I don't think it really is slow though. So we need to figure this out. We need to get to the bottom of this. Depending on what this soup is doing to me right now, I may need to run to the bathroom, but we'll see how far we get. That needs to move. Do that. Just get it mostly out of the way. Probably just minimize it. Not pay attention to it today. Simucube firmware. I wonder if maybe if I plug in the pedals, if it'll work out some of the other stuff that's going on with this. We're having a massive heat wave here, I guess. It's absolutely awful outside. It is terrible. It was like 8 a.m. and it was just the worst. Around 4 to 6 p.m. we're gonna get rain. Okay. Yeah, it's gonna get up to like 88 degrees. What's the humidity? 60%. Ugh. Insta death. No, I don't take those requests. That is a cute font, though. That is a very cute font. It's very hard to read, though. That's very hard to. That's very difficult to read. He's driving out to buy fireworks. Oh God. I don't know. I'm going as long as it takes, man. We got some work to do, and I intend to do it. I think we're in a decent enough place that I'm going to be able to get all the stuff that I want to get done. And we may have a working thing. Push comes to shove, might even pop the stream down, set up, and then do a game stream. But it depends. 2 trips last time because he was afraid of getting caught with $2,000 in fireworks. What the hell? Jeez. Well, exercise some caution, because boy oh boy, are there some grody pictures that come out of the internet after 4th of July. I'm not feeling very I'm not feeling very much in the mood for 4th of July this year. Let's be honest. All right, let's see here. So, all that stuff. I don't really think we need to look up anything on the Linbus protocol. We're gonna have to dive into my code from a little while ago, but love to watch fireworks. Afraid to see drunk people hanging out with it. Yeah, there's some fun gifts that come out of the internet after the celebrations. Bottle rockets going into people's windows. Whole streets, blocks exploding. I've worked with some remote ignition systems before. Smartphone enabled? No, thank you. Okay, I haven't seen this one. This one's some kind of a supplement. The one that I saw was... I don't like that. It's a little too fancy looking. It's a little less utilitarian in nature. Push pins and I don't know. I don't know about that. It seems like it's meant to sell slick looking hardware instead of being like an industrial system. Now, the one I worked with, the igniter battery door had a bad design in it, and one of the AA batteries that was put in there was on a really hard spring, and so it broke the bolster. So I had to make a whole thing out of hot glue in order to hold it on. What is the strand of hair? Can you stay like right there? Okay, I had to make like a whole bolster for it with hot glue, which was like, I don't know. I mean, it worked, but. Let's see here. Got my code open? Yeah, there it is. I don't need the Linduino stuff. I got all that stuff in there. We haven't heard anything from the shifter yet. So I'm wondering about that. One sec. all the oils from the pho, along with the pepper stuff, has gotten me to coughing. What was that thing? It has Wi-Fi, right? That's all there is? Or is it super revolutionary and new and crazy and stupid? I have a bunch of Pi Picos, but they're not Wi-Fi. Which I don't know. To a certain degree, you gotta let go of the part of your brain that wants to keep up with the Joneses on everything, right? Like, what am I gonna do with Wi-Fi on that thing? I mean, there's a lot. I've done a lot of stuff with ESPs, but I don't know. Yeah, it is nice to see a competitor to the ESP because there's not a whole lot of ground to be given there. I mean, the ESP is Wi-Fi and it's $1. Like, what else do you want? More pins, and that's what the Pico has. And Python, I guess, and just, you know, using it like a USB thumb drive, throw code into, which is pretty cool. Does it run slower like Python does, or is MicroPython? I don't know what the deal with MicroPython is. I haven't really looked it up. Yeah, I didn't really think there were many other places to go from the ESP, but everyone's innovating. It's good. It's a good thing. Innovation, good. Good. ESP can run USB hosts? I didn't know that. Python's over your head. Python is like, if you can code, you can code in Python. It's not that bad. You just need to immerse yourself in it a little bit, that's all. It's very rudimentary, not rudimentary, but it's like, it's very capable. It's just slightly different from what you're used to, I'm sure. And then it's got kind of a flow to it that's really nice when you're rapid prototyping. When you get into it, and again, I haven't done Python in a long time. We're gonna be looking at Python. I'm gonna be relearning Python for Burn the Subs when we get back to it. As when I got into stride with Python, okay, so it's going through the text, which means that it is slow. And physical computing is a lot of fun with Python because there's a language to it. There's a flow to it where you think, well, I need to do this, so I need to go through this thing and do this and do that, and it just kind of like falls into place. It's very easy to come up with the logic of your code with MicroPython. I like it a lot. I think it's a decent transition into sort of your more hardcore C's and C++s. However, my only concern with that progression of languages is that Python teaches you bad habits. You're gonna spend a lot of time figuring out the habit of putting a semicolon at the end of each line, you know? Stuff like that. I'm no expert. Zilkovich music, yes. This is Julian. This is a buddy of mine. Playing around with his music gear. He knows his stuff. Keyboard and mouse. It's a mouse and keyboard for the Amiga. It also connects to a joystick port working on the right. Bluetooth codes, so I can use PS4. Oh Jesus, it's confusing. It's a lot of stuff. That's a lot of stuff. It is a scorcher out there. I am spending my time inside, and I'm proclaiming that as if it's anything new. As if I've made a conscious choice to do so today. This is what I've been doing anyway. But instead, we get to make a little bit of progress on this wheel today. So I'm excited about that. I'm excited to make some progress. I bought pho for lunch, which is a treat. Turns out their prices aren't wildly fucking fluctuating like everywhere else, which is nice. I don't know, something about the oils and the peppers and the noodles and everything else. I just had a cacophony of clearing out every single cavity in my face. There's a lot of coughing that went on. I feel like maybe a hair got down, you know, into the works, but I can't be sure anymore. I got all night. I got all night to work on this. I don't got nothing else going on. Nobody's pestering me about anything else. So, we gotta get this thing working. We gotta get this thing running. We're perfectly capable of doing it. I don't understand what the holdup is on this entire project. For what? You're just asking me out of the blue if I'm using a dedicated level shifter IC? For what? What do you mean? If you mean with like the serial signals for the Bluetooth stuff? Oh, for Celia's thing. Okay, that's who you're talking to. That's confusing. Vibing. So somebody was using some kind of, I don't even know what it was. It must have been like a power washer. I couldn't exactly hear what was going on there. I think I heard the shh of a power washer, but it was making a dentist drill noise. It was a high-pitched squeal. I thought I had a wall wart that was going to explode. I was poking around every corner of the house, trying to look for this wall wart that clearly has capacitor damage because it's making such a racket. I thought I was gonna have a smoky, fiery explosion, and it was no wonder that the house hadn't burnt down previously. But instead, the noise turned out to be like blocks away and somebody using a power washer, la-di-da, no care in the world. Man, noise pollution, good Lord. I was ready, like I was just ready to gnaw my own arm off to get out of this because that squeal was a high-pitched dentist drill. And it was so subtle, even the fan couldn't drown it out. I wanted to die. All right, just a couple more minutes and then we'll jump into the project because we do have a lot to do. I have a little bit of soldering to do. I have a little bit of building to do. Maybe we should take the circuit board off too. We should probably take the circuit board off. That'll make it a little easier for me to do my job. Adding basically a troubleshooting header to the side of the chip. And that way, we'll have a place where we can put all of our scope probes, and that we'll get a nice readout of everything that's happening. And I'll have to figure out what the timing requisites are on the LIN bus stuff again in order to get everything on the scope and looking good. Then we jump into the code and we put little diagnostic pulses out in order to get the scope to sync into the right spot so that we can observe what's going on. It's a whole bunch of bullshit is what it is. My code should be more capable. My serial one-wire LIN bus, etc's should be stable enough that they're able to deal with whatever the hell is going on, but we have absolutely no idea what's going on. I don't know what's wrong with the timings. So we'll have to see what's going on. We're not going to use we don't have to use the logic sniffer. We're not doing anything that requires a logic sniffer. Logic sniffer's for getting data out of a signal line. We don't need to get data out of it. We need timings. I mean, technically, we probably could use the logic sniffer. It would just be a little bit more annoying than just having a scope rolling. We need is a rolling scope. Look at him. Look at him adjusting stuff with his little hands. Look at him go. He's so precocious like that. He's actually really, really short. He's reaching up. He's reaching up to the desk in order to get to it. Actually, Julian and I are about the same height. We are the only people in the group of friends that I have that are about human height. Everybody else is like 7 feet tall. They're all like fucking basketball players for some reason. I hang out with my friends and I'm like, what is going on? Why am I like I'm like that what's his name meme where he's like looking up at the whatever. Anyway. Only I don't have muscles. That's the thing. I'm not short. I'm a good height. A normal height. I'm a normal person. I'm a human, and my name is Annie. Or no, I'm a person. Hold on, seeing if I have to cough. It's like once I sit still, all the post-nasal drip stuff causes me to cough again. I think I'm good for right now. Why are the clouds moving down? That's not the direction the clouds should be moving. Wait, that's also not the direction of the clouds. These are not the right direction. It really looks like he's like under the table. He's reaching up. He's like Jim Hensoning it. He's like down there with a little video monitor, operating things above his head. So, our ability to press buttons within the system is good, right? Our serial communications work. We need to work on the LIN bus stuff, because for some reason, it's unable to be intermittently operated in the way that we want it to. Whereas, when I had it working before, it was pretty reliable. So something's different. Something's either not happening properly, or it's not being initiated properly. I don't even have a start soon up right now, so I guess technically I could say that I started the stream. Let's just fade the ambience out, because this is a little bit more easygoing ambience, and I'm gonna hit pause on that. We'll go to the face cam. Hello, guy, who's in the booth today? Can we go to the? Oh, okay, there we go. They got it. They found the button. All right, so here's the deal. Everything works individually. The only problem is, I hate how that's just the comment that just sticks on the bottom of chat. This is a problem with having a smaller stream, is that nobody's saying anything, and so my chat just stagnates. I need it to fade out. I need to figure out that. I'll figure that out soon. Anyway, what's going on with the steering wheel right now? We need to finish the project, right? So we got all the individual parts working. We got them all together. We put everything together. It's all ready to go, right? And it works. We can push buttons on the steering wheel, and we can see buttons being pressed digitally within the system. The thing is, that serial signal through the wireless module was very fast. Oh God, not these fucking things. Bonk. Anyway, it was very... Are you fucking kidding me? Am I gonna have to get the machine gun? Like, damn. That was 2 in a row. And let me guess, the accounts are probably dead by now. Anyway, fuckers. Anyway. Yeah, I want to buy users. You found me, finally. Yeah, isn't that illegal? Now there's 2 of them. 45 viewers is like the sweet spot for these motherfuckers. All right, anyway, here's the deal. Everything works. Nothing works. When you connect a wireless module to this thing, snappy. It boom, 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 you know? You hit a button, you release a button, quick, real quick. Bam, ba-bam, 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 ba-bam. Everything works perfectly fine. When we have it pull the LIN bus, it slows down significantly. Now, we should be going through at a pretty regular interval. Our LIN bus code is very light. It is bit-banged, which means that we are manually taking over all the signaling that's going on. But we're getting in there, we're getting all our 1s and 0s, and we're doing it on a very fundamental level. We only have 3 devices on the LIN bus. And 3 devices, and the amount of bytes that they have to report back should be very quick. It does not appear to be very quick. Some of the buttons are also a little weirdly intermittent. Like I'll hit a button and then 2 buttons will go back and forth and back and forth. So what we need to do, they're learning. Yeah. If I say my chat is dead, does that mean that these things suddenly come out? Is it an AI on the audio stream that's like pulling old accounts out of inactivity in order to, we got a trigger on our word. Let's activate a couple zombies to go try to sell accounts. Very weird. Maybe they just saw that I had X many viewers and the chat wasn't moving. I don't know. Yeah, we try to ban bots here. OctoJ comes through and regularly bans like a group of bots. But there's too many to fully get rid of. The reason that we do that is because when you gift subs on this channel, the giftees will end up on the board. And so we want those to go to humans. We don't want them to go to a bunch of bot accounts. So if we ban the bots, they still count as viewers, but they don't get gift subs. That's the important part. That's why we do that. So anyway, I'm looking a little knackered today. I'm kind of, woke up under the bed and all that fun stuff. And it's a heat wave and I left the window open. So we've got a pretty simple task ahead of us today. And it's gonna take a couple different forms. We start off, we need to do a little revision to the circuit board. I need to put in some test points so that I can plug in my scope probes. And then what I can do within the teensy is I can set off a pin to let out just a microsecond spike that we then trigger the scope off of. And that microsecond spike, that microsecond spike, the little microsecond pulse, can help us look at different parts of the code and figure out what's being recognized within the microcontroller. So we can adjust our timing that way. Unfortunately, that's the form that this has to take. The LIN bus master is supposed to be the thing that sort of determines what all of that external timing is. And for some reason, it's just not working. Like our shifter isn't coming back with any shifties. Our our steering wheel is reporting button presses, but the ones that are earlier in the packet, the ones that are later in the packet, it seems like there's a timing discrepancy. Like we're off by a lot. So I need to figure out what direction we're off by. And what amount we're off by. So the scope's the best way for us to probe that out. That's what we've done in the past. I just thought we had it on lockdown. I thought we had it in a state where we said, if I request LIN bus, we know it's going to reply in kind. Because that's what we did before we worked on the digital button pressing. Oh well, if we can tune this up, and if this isn't a very long task, perhaps, and I'm not going to make any promises, it's probably not going to happen, but just in case, I might stop the stream, set up the wheel on the desk, and start it up again, and we do some My Summer Car. We'll have to see where we get to. I've got dinner. I've ordered enough food to be lunch and dinner. I've eaten a modest lunch, and I am ready to go. I'm ready to go, and it's just me today. It's just me. So all my friends are dead. No, I think they're all doing stuff this holiday weekend. I think they're all busy this holiday weekend. Everybody's got to go do stuff with the family. I told my family to fuck off. I got to stream. Also, I'm not feeling very patriotic. All right, so we got our scope probes. I need to get headers down here. That's these things up here. We need to get the circuit board out of here. All things considered, by now, I probably should have made a circuit board for this thing. It would be a lot cleaner. It'd be a lot cleaner and smaller if I could just make my own circuit board for this thing. You know, there comes a time. There comes a time in every project when the consideration is whether or not I should have spent my time making a circuit board. Although, to be fair, this project wasn't done, so... I.O., let's go. Shoot him in the back now? What they want, I don't know. Yes, I too have been to a sports game before. How's it going, 3 minutes? All right. Oh yeah, let me move the camera so you're not looking at my shoulder the whole time. Yeah, my math teacher used to be on the lacrosse team, believe it or not. So we'd go see lacrosse, a lot of lacrosse games. One of his students was complaining, or they gifted him like a New Yorker cartoon that was framed. But then they had a test where we were supposed to identify if the triangles were isosceles or whatever else, you know, the types of triangles. And he happened to have a protractor, and he got it out and he measured. And so the equilateral triangle was off by like a millimeter. And so he threw up a whole stink. Being that the math teacher was a lacrosse teacher, he also had temper issues. Or he was a professional lacrosse player. He had temper issues. So he threw that framed picture against the wall and broke it. School. I need to mark this. I'm gonna forget where this goes if I don't mark it. Hold on, let me get a marker. No, I'm not. What the fuck are you talking about? Why would I ever CNC a PCB? Why would I ever do that? That's so dumb. I mean, come on, chat. Come on, you guys are better than this. You know what we're like around here. I don't have the ability. I mean, I could eventually CNC my mill. That would be great and all. That's a huge undertaking. Hundreds and hundreds of dollars would be spent on that. And then it's loud and it's obnoxious and it makes a lot of dust. You guys know what we're all about around here. PCBs are $5 and you spend like $1 on them to get them shipped. Like for like a couple bucks, okay, 25 bucks, I can get pro circuit boards shipped to my door in a little gift basket, right? It's just that easy. Oh God, I'm never gonna remember where these go. I think I have them labeled, but just try to keep them in order like that. I feel like you guys just want to mention stuff that you know about and get acknowledged. Oh no, oh bother's gonna use a MOSFET in a push-pull pattern. Because I just learned about that in class. Okay, so we're gonna put a test header right here because we got a little bit of space. All right. Now if I really wanted to, I could pull this all into Fusion 360. I don't have all these boards in Fusion 360. I'd probably have to half-ass a lot of the stuff on it. I mean, I guess I don't really need to care, because there's a lot of space here, but I could probably make this entire thing, like, much, much smaller. Probably put some stuff on different layers and things like that. As it is right now, this is just a big test board. We have our port expander all the way out here. We've got the two I2C potentiometers. Those are all hooked up to the external connections of the simucube. We have a header on the bottom here for serial. So I've got my TX and RX, but I don't really have them marked all that well. That's going to plug into where the TX and RX module plugs into. And then got a couple things going on over here. Two of the pins over here are the TX and the RX for the serial module. Then we also have the LIN bus TX and RX right next to it. It's all on these 4 pins right here. I kind of want to move all that stuff over and out here. I could try to put a header like right next to this thing. No, that's not a good idea. There's also I2C coming out of this too. But I don't think we're really going to concern ourselves with troubleshooting I2C. I need to have all of the LIN bus and the serial ports accessible. So I think what I'm going to do is jump serial over to here, get LIN from here and jump it over to here, and then I'll have a 5-pin header with ground in the middle, and that'll give me the ability to run all of my external signals on this thing. I think that's what we need to do. Now, do we have any headers that'll sort of help me have the header be on the top layer of the board? No, of course not. This one might. Yeah. That one will help. I mean, it's going to be significantly weaker being on the top of the board, since the anchor is just going to be whatever the interface between the circuit. This is actually exactly 5 pins, too. That's nice. Oh, I also need to get something to plug it into. Here's an important tip, chat. Here's an important tip. This one will take you far. If you're going to be soldering pin headers, you'll want to plug them into something. The reasoning behind that is that there's a lot of heat involved in soldering. And you want something to either take the heat away or hold the thing in a position where it's not going to get distorted. Because if I go to solder this right now without something holding on to it, that plastic will get soft and those pins will start moving out of the way. You've got your Twitch handle is engineering AF. I mean, Woody Basket has the excuse of just being a basket weaver. Engineering as fuck. Like, how could you not follow along a little bit? Anyway, all right. Man, I'm like about to start like fucking coughing. I really did a number on myself, and it was just, I just had soup. It was just soup. All right, so let's see. We got thermals here. We got the microscope. I think we have everything ready to go. Yeah, no, we don't. There's no need to do manufacturing of PCs because of the advent of $5 PCs. I mean, $5 PCs have just like totally ruined it for any of the people who wanted to get into home manufacturing of PCs. It's something that we get a lot around here, is people coming in here and going, you know, when are you going to manufacture your own PCB? Or when are you going to CNC that? When are you going to get this? Hey, should I buy a $6,000 PCB CNC? The answer is no. No to all of that. To all of that. No, no, absolutely not. None of it. Because you just send your design to somebody else, and in a week you get a perfect PCB. Like, they're amazing. So yeah. Delays in projects like a week. 5 days. You can wait. You can wait 5 days. Man. Wait 5 days. I've been waiting 65 years for Star Citizen to come out. All right, let's see. So, regular size soldering iron's totally fine for this. Just gonna use a normal tip. You can see it heat up almost instantly because I have an expensive soldering iron. And I got a nice high wattage soldering iron because I use it almost every day. Where are we gonna mount this thing? I mean, I could put it right up against the tape. The tape is getting out into a little bit. I want to have a little bit of room for the wires over here. There's plenty of space on this board. So let's just wang jangle this thing just right here. We'll just put it right here. There's absolutely no way you can convince me that I need to keep those kinds of dangerous PCB etchants in my shop. I hate having dangerous chemicals. Looks directly across from where he is at fucking the methyl ethyl ketone that he's got sitting right on his desk in front of his face. Hey, Turbo Nad, raiding with a party of 22 individuals. 22 individual souls come here to die. How you doing? We're trying to finish up the wheel. If I can get it working, I would very much like to be doing a My Summer Car stream today. But right now, I'm yelling at chat for being assholes. No, they're fine. They're being fine. But, excuse me. So, what I'm due is add a header on this thing that will allow me to troubleshoot some of the digital protocols that are running around on this board. So one of them is serial. The other one is called LINBus. It's called the Local Interconnect Network. By the way, for those of you who don't have an intro, I mean, I see Woody Basket here, who's from another streamer who shall not be named. It's just somebody that I enjoy watching. My soldering iron just fucking flew out of my hand. I should give a little context, because I don't know how much you guys know about the system that I've got going on here. We've been working for like months, probably years, on this direct drive feedback steering wheel system. This started as a dual joystick. This started as a dual joystick setup that clipped to the side of my desk. It uses these Bessie clips, right? And it locks down these two bars on the desk. And the reason that I have a crossbeam on them is that my old joystick was the X65F, which is it is a force sensing joystick. So what would happen is you would go to turn, you had no idea that you were giving it the most amount of turning available, and so you kept pushing the stick harder and harder. And so eventually something like a desk clip would just like bleh. And so what I did is I put a crossbeam in it, which made it like way more solid on the whole thing. It still led to me like white knuckle, like with like tired finger muscles and stuff. It was really, I don't know, the X65F had that problem where you didn't know how much force you were putting into the damn thing. It needed to have like a little buzz, like a force feedback on it that told you that you hit lock, so that you could calm the fuck down, you know? So anyway, so dual joystick setup. I eventually upgraded that to be anodized rails, and so I had this stuff left over. In addition to that, started playing my summer car, and I went, you know, this thing would control really well with like a steering wheel controller. What's available out there? I looked at some Logitech systems, and I went, you know what? This is expensive. I wonder what I can DIY. Looked around, turns out Open Wheel Project was a thing. Open Wheel Project led me to the Granite Devices simucube controller, which is just a little bit fancier of a way to put all the components that are involved in the Open Wheel Project onto a singular circuit board that takes the voltages and has the resistors and the capacitors and all that fun stuff on it. So the Granite Devices simucube controller led me to eBay in order to get a 3-phase motor. And the 3-phase motor happened to be a 2-horsepower Mitsubishi Mel servo, which is a lot more motor than you will typically find on your force feedback steering wheel systems. You see, you can get a much more powerful motor. Companies do not want to sell you a much more powerful motor, even though the expenditure is not that much more. The weight is a problem. They can't ship it anywhere because it needs to be like crated. So anyway, big motor, big spindle, one moving part. Pretty cool. Now, that moving part is connected to a Mercedes S-Class steering wheel, a refurbished S-Class steering wheel that comes from, I want to say, Croatia. There's somebody in Croatia back in the day that used to refurbish steering wheels and sell them on eBay. There's probably a lot of people that do that, let's be honest. So I bought this for pretty cheap, and the reason that I bought it is that it's got the paddles on it for shifting if I want to do super duper sports car roleplay, or I've got a lot of buttons on this thing, and I can use all those buttons in order to navigate stuff. Turns out this thing multiplexes its buttons in a very weird way, so it's hard to directly access these buttons, the ones and the zeros that are coming back from the boards that are behind these things. So I wanted to take over the electronics that were already there. I found a chip on there. It said it spoke the LIN bus, so LIN bus it spaketh. LIN bus is a local interconnect network, LIN, bus system that actually works off of the LIN bus system is a one-wire protocol. You get power, you get ground, you get signal. 3 wires, 1, 2, 3, ba-bam. Those 3 wires carry everything you need. I mean, the power is to power all the... I am in the middle of something right now. I do not need you. Oh, look at what's going on with my glucose level. Hold on, 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 hold on. Okay. Anyway, LIN bus. It uses one wire to do cross communications. It basically says, wake up, here's your timing, I need to speak to this device. That device replies, right? So we have that system running to the steering wheel. We were able to reverse engineer how to get all of the button presses on that system into our microcontroller that we piggybacked onto the back of the Granite Devices controller. So we were able to physically press buttons because they got these Ethernet connectors where they want you to connect the button to ground. And so you flip a button and it connects it to ground. That's a very rudimentary system. We were able to get that functioning. Problem is, there's like 15 buttons on this thing. 15 bucks, little man. There's like 15 buttons on this little thing. And then on top of that, I have another actual car part, an E46M3 Steptronic shifter that we were using. Now, it turns out I'm actually very terrible at getting straight which one's plus and minus in terms of shifting gears. So we swapped it out for an 8-speed shifter, but that'll come in a minute. So we reverse engineered this thing, and in order to get that thing hooked up to the Granite Devices controller, well, we already got the LIN bus running, so why don't we just make an accessory? This has been a long project on this stream, and it has come to fruition. We have, I got the first place junior rally in my summer car. Now I've got my eyes on that senior rally. I want to be the guy. I want to be first place. So what I did is I found on Thingiverse a 3D printed 8-speed shifter. By the way, I've also got real car pedals over there. That was another recent thing. Those are E92 pedals. So they're BMW, they're actual car pedals that strap to my office chair. Okay, so all of that considered, and that's also that's also a LIN bus accessory that we made up. And that's what controls the little digital potentiometers over here. Because the Granted Devices controller wants you to plug in like simple stuff. It wants you to plug in switches that are connected to ground. It wants you to plug in just potentiometers that give you just a simple voltage level back for how far your pedals and stuff are. And that's all well and good for most people, but we went a little crazy. We went a little crazy here, you know? So I've spent a lot of time figuring out how the system works. Problem is, we have too many buttons. Not that many button inputs in the Granted Devices controller. It's probably like 15. 15 we have just in the steering wheel alone. So what I've had to do, and I didn't have to do it, but I did it, is reverse engineer their Bluetooth low energy wireless wheel module. The wireless wheel module is a way to make your steering wheel for your race setup into a battery operated device. You charge your wheel up, you get it to connect to this thing. When you press a button on the wheel, it'll press a button. It'll tell the base station their button's been pressed. So Bluetooth Low Energy is a known protocol. It's a known API. We know all the ones and the zeros to speak back and forth with it, right? Well, problem is there's a lot of projects that are Bluetooth Low Energy, but they're not trying to fake being a module. We had to fake being a module. So over the past month, I have been working tirelessly in order to try to fake out this base station into thinking that the Bluetooth Low Energy module is actually plugged into it. And we succeeded. We succeeded yesterday. We just barely fucking got it to work. We did. It works. It works. End of story, right? No, wrong. There's still something wrong with the timing. The LIN bus stuff broke. I put everything together in one giant, massive program, right? One big Arduino, one big lazy Arduino program. And it all worked, didn't work. So what we're doing right now, what we're doing today is I'm adding a header to the circuit board that's going to allow me to plug the oscilloscope in. We'll put some little pulses onto the line at certain indicators of the digital signal, and we'll get the LIN bus stuff tuned up. I don't think it's going to take us very long. Hey, what are we doing today? All right, so you guys, this is my steering wheel setup, and no, I'm not going to start over. So anyway, I need to add headers here so that I can plug the scope in, and then we'll work on the code with this thing, and we'll tune it up. And this could be very quick. This could work very quickly. If it does, stream goes down. I set everything up at the desk and wipe off the desk because there's like pho. Like I had soup for lunch, and it basically looks like a cafe explosion on my desk. So anyway, clean up my desk, give it a wipe down, you know, disinfect it a little bit. Maybe like Febreze on the chair to get all my farts out of the chair, and then I can like put up the stream again, and maybe we can play My Summer Car. If my brain is not gelatinous by the end of this. So I think if we sit down right now and we do this and we get it working, then by God, I think that's within our sights today. Unless something heinous happens, like if my hand falls off, I'll need to go into rehab. So give you motivation? I mean, look, man, motivation is a bunch of bullshit. If you want to get the stuff done that you need to get done in life, you need to be able to just force yourself to do it, motivation or not. I know all great motivational art is something to beholden, but it's rare. You're not really going to run into that. You need to just power. You just power through. I don't know. I was just thinking of what would look like. There's like a lot of like oils and stuff just all over the place. Just like a soup cafe explodes. I don't know. Do your research. I'm not an Encyclopedium Britannica. I don't know things. More pixels. Is it? I don't know. I mean, the camera. I think I calibrated this one, although it's looking a little streaky. But this will luckily the right angle pins will hold it down to 2 pads instead of 1. But these are single-sided, so they're really not strong. So eventually this will break off. But I think if I'm just hooking probes up to this, it should be okay. It's like 2 o'clock East. It's like 1:30 East Coast. Why are you gonna? Whatever, Dins. You do you, man. You people on Twitch baffle me with your sleep schedules. You baffle me. All right, so what we're doing here is we're adding a little right angle header. I'm going to put ground in the middle of this, and then we'll put our 2 serial signals on either end. Actually, I need 6 pins. Shit. I need 3 for the... Maybe we'll put a ground lug elsewhere. Ah, damn it. I need 1 more pin, and I can't exactly just add a pin to this. Because I need LIN bus, but then I also need my diagnostic 1-0 pin, right? So I'll need like ground maybe as a separate thing. Yeah, welcome to the correct time zone, exactly. East Coast is the heart of civilization. All right, it's only a little crooked. Well, I hate your coast, whichever coast your landlocked fucking state is on. All right, let's see. All right, so how do I add a pin to this? Well, the problem is I'm not gonna have that plastic thing there. Not gonna have the plastic thing, and I'm out of right angle headers. Oh, these are totally pointless in the... It's not gonna work. What's up, Pilly Belly? East Coast of the UK. What am I gonna use? I need a like a right angle pin header, and I just used up the 5 pin that I had, and it should have been a 6 pin. I have regrets. I have my regrets now. Well, keep hunting, but I don't think I'm gonna find much because I don't have a lot of those. Let's just see here. Yeah. I guess I'll put in like a 2-pin ground lug or something. It's like the best thing that I got. That's all I got right now. Is just add a put like a little 2-pin. Oh, this is a breadboarding accessory. That should go in here. West Coast of Sweden. You guys don't have an East Coast. I guess you do. Danube Coast and Bavaria. Oh, shit. You guys got some weird exotic coasts going on here, man. All right. Let's see here. Why would you wake up at 3 in the morning? What's wrong with you? Why are you blaming us for that? Jeez. Okay, let's see here. I need a right angle header, and I don't have one of the nature that I'm looking for. All right, so just a regular one, just a regular header, just a regular square pin header. They got to be square pins because the round pin headers are great for like thing-to-thing connections, but they're not great for like probes and DuPont connectors. So, Dins, you're tired. Go away. Go sleep or something. Jeez. He's like cranky. He needs a nap. He's gonna start really like going psycho like a toddler, and then he'll just fall asleep in place. Yeah, we'll just hoist it like right there. It's gonna be a little sloppy, but we can make it work. We can make it work. Just like that. Just use the header to hold it up. The whole thing is crooked. I'm not going to fix that, but it is going to bug the hell out of me. That's going to bug me, but I need to get this done. Is my head's going to block this camera. I'm going to move this camera in. I like to have this camera here for hand techniques. Oh, God, it is really, really crooked, though. Nope, I gotta just live with it. I have to just live with it. I have to live with it. Otherwise, I'm gonna spend all afternoon soldering one header on and making it perfect. Whereas I could have spent that afternoon designing a circuit board, a printed circuit board for this, and just ordered it up, which I should have done ages ago. And that could just have test headers on it too. Yeah, I really should have done that ages ago, because that would have been a good thing to have. Good thing to have. All right, so I got a ground that's local. It's right here. So I can just run some wire on the top of this thing. I just need to make sure that that's a ground. I have absolutely no idea if that's ground or not. I don't know if that's ground. All right, I'm gonna have to ohm it out. We're gonna have to ohm it out. When in doubt. When in doubt, ohm it out. Multimeter, ohm mode, untangle my wires, tangled in everything. Oh my God, how did that get in there? Okay, let's get that out. And then my lacerating probes. These things are horrible. They'll put holes in your hands, which is good because they blast through that layer of oxidation that sometimes exists on electronics. So from here to here, half an ohm. Oh my God. Yeah, that means that's connected. So, all right. Are there any stray little bits of wire? Whenever we work on stuff like this, there's usually like little stray bits of wire sitting around that I can cannibalize and turn into... All right, there aren't. So I'll have to get some new stuff. There. This is 30 gauge wire wrap wire. I find that this is the good stuff. It's a good place to be for building little perforated prototyping boards. Yeah, they're high voltage, actually. They're supposed to get you further away from the power stuff and protect you. But I like them because they are sharp. And not sharp like they're smart. They're sharp like they will hurt you. Like I've been hurt in the past. All right, any old wire will do, because this stuff is just going to get exposed to the outside world. And then we'll need to pull in more wires in order to connect all of the digital stuff. Now, the reason that I want to do this on the top layers because I want to have color coding on the wires, because I definitely want to know which one is which, although I won't be able to see which ones are the LIN bus ones. Either way, I want some kind of an indicator to myself that they are different, you know, protocols or different identities to the wires. I don't know. We'll see how well that goes. We'll see how well that goes. But I also want to get this done quickly. So, all right, let's go back to the microscope. I'm running out of working space. I'm starting to get like, I'm getting crowded into the corner of my desktop surface as I do more and more of this. But this is good. We're approaching the end of the project. We're getting there. We're getting to the end of it all. We're going to be able to complete this thing, I hope. And then I'll think about in the future making a PCB for this whole thing, because I think that is a good place for this to go. You know, once we get everything working. And if people are interested in it, which they won't be, I could sell it. They really won't be. Nobody else is doing this. Hey, thank you guys for the follows. Appreciate that. We're having a weekend project stream. I try to do games today just because I do enough work during the week, but this is like the 11th and a half hour of a project, and I just can't stop. Won't stop. Rocket to the bang bang boogie. But yeah, what I was saying earlier, I mean, I take very closely to heart. Motivation cannot be relied upon. Routine, habit, and just being adamant about figuring something out is going to pull you further through. I mean, it's the same thing that all these self-employed people will tell you. Is like, you just got to do it. You can't rely on motivation unless it's some piece of art. My throat is getting extremely dry from the hyperglycemia. Thank you, diabetes. Appreciate you. I gotta pull that wire in a little bit. That's a little sloppy. Then again, this entire board is sloppy. This thing is a test setup. Why did I emphasize that? Weird. Right, there we go. And metal fatigue. Metal fatigue. Metal fatigue. I bought Outlast last night. I don't know when I'm gonna play that. I was watching some old prereq stuff, and Outlast came up, and I was like, you know, well, it's kind of cool. I don't know if I'll ever get to play it, but the whole collection was $7, so I guess that's all right. Looks pretty atmospheric, pretty horror-y. Okay, there's our ground. So now both of those connections are ground. And that's just me accidentally forgetting to put a ground on the rest of the setup. So adding 2 ground lugs helps cover over my mistakes. It's as if I intentionally meant for it to be like this. So now we have 3 pins. One is for the test pulse pin that's coming directly off of the, well, they're all coming directly off the Arduino, but we have a test pulse. Then we have TX and RX for the LIN bus, and then we have TX and RX for the serial. So it's a one-stop shop for all of my troubleshooting needs. Now, the serial stuff is right over here, even though that also goes back to here. I could just get all of them from right there, and then pin 6 is the one that we are using as our pulse pin. I guess I could just get them from there, but that's going to be a major pain for me to solder, I think. I might just get the 2 from here and then go over to here and get these 2 from the pin header, because then I can just jump them around and put them right to there. You know, jump up. Yeah, jump up and then get down. Jump, jump, jump. Yeah, all right. Okay, so blue and white wire. Blue and white wire. Got him. I need to make a little thing for the front of this, for the front of all the spools, so that it can hold the individual pieces of wire in place without them, you know, going all over. It would be nice if I had like a little pinch cleat that could hold them on the top of the reels, and that way I wouldn't have to rely on them getting pinched down there in order to not unspool and get tangled and everything. That'd be swell. We'll figure that out one day. One day when I have all the time in the world. 5,000 projects a minute. I mean, that could be a one-day build, too. That could easily be a one-day build. I just throw something into CAD that screws down onto the maker beam, make it look pretty, and then hit print, and it's done. Or I need to adjust it 500 times, and then it's done. All right, simple as sewing. Probably have to come back and clean that up later, but that one goes to the top, to the very top. I really have to ignore the fact that this entire thing is leaning over like that. That is so triggering to me, and it just is not necessary for me to fix. I need to remember that this thing is like the prototypiest of prototypes. It does not need to be pretty. All right, so just like sewing, pull it tight over there like that. Clip the wire to length. Doesn't need to be too long. Hold on, where's that going? That goes like that. Give it a clip. And then actually, because this thing is a little longer, I can just strip it in place. I can just use my fingernails. Probably shouldn't use your fingernails to do this, but, well, there you go. A little bit exposed there. Once I tin the end of the wire, the jacket is going to pull back even more. So got to be cognizant of that. Probably don't need the big length of white wire. I can use this little scrap that I got earlier. So that little scrap, take that, bend the end with the tweezers. You guys can barely see what's going on. It's going to be like 1 pixel here, but most of this stuff involves larger movements than what typically goes on the microscope. So it's better if I have this view. You guys can actually see what I'm doing instead of a giant hand coming in and blocking the whole camera. I need like a partial zoom for you guys. Okay, solder. Punch that down. Basically, I'm just temporarily holding it in place. Ow, that really heated. That's a actual, not an actual burn, but it, you can't see the heat anymore. It's always fun when I do that. You accidentally heat up your hand and are able to show it on the thermal camera. Okay, let's go over here. Dat Deets! Oh my god. It's one of the first badge holders on my channel. My channel where I stream things. Dat Deets. Dude, thank you for the 50 months. Thank you. I'll put it up to no good. All of that contribution to my efforts here. That is my promise to you. All right, so now we need the pulse signal. I guess we'll use a purple wire for that one. It's all for you, bother. No, it's all for evil. It's all for bad things. It goes to weird stuff. I buy like hard candy with it. That's all I do with the money, is I buy hard candies. Werther's Original. All right, so it's pin 6, and the bottom of this row is pin 12. So it's 11, 10, 9, 8, 7, 6. It's that one right there. The reason that I'm doing this is that the last time we tried this, last time I tried to like get some good diagnostics out of this thing, we used clips, little clips that clip onto the sides of these, and it like blew up. It like exploded. The fucking thing fucking detonated because I accidentally, this stuff is like 50 volts, right? It's like 48 volt. This is a 48 volt power supply. So there's like 48 volts and 12 volts and 5 volts. It's all jumbled about on this side of the board. And this is where all of our TXs and RXs are coming from. And so I had clips on stuff, but then they would slip off and it like hit other stuff and we almost had a fire. So I'm putting a header on the low voltage side of the board that's nice and chunky so that we can get all of our connections on here without it being a risk. Okay, hold on. I'm trying to do my toxically masculine voice, but it's irritating my throat. So I gotta go back to my normal voice. All right, chat, so let's get the end of this wire tinned. No, this is my normal voice, but it's when I'm talking at theater volume, which is how I stream, I yell at the furniture. That's streaming, by the way. It's yelling at your furniture. I'm yelling at the furniture in the theater volume so that my voice is crisp and clear in this little lapel microphone. No, I lost the wire position. Well, it's fine. We didn't really do anything with it yet. We didn't do anything yet. So, 12, 11, 10, 9, 8, 7, 6. Right at the edge of the pins. So I'm going to get that right there. Now we can always change the pin number if I accidentally solder this to the wrong thing. There's not a whole lot, like we're doing a lot of digital stuff with this microcontroller. So the physical pins are not being taken up by a lot of different tasks, which is why I kind of wanted to add some more LED indicators to this thing. But that takes time to do. So instead of doing that, we're gonna get this going. Hopefully we'll do some good stuff with it. I need to actually solder that a little further back. I'm looking at this with Mark 1 eyeballs right now. When I use the microscope, you guys are viewing it through the same camera that I do. So it's not special. You know, I don't have like any kind of an enhanced view. I am looking at it in exactly the same way you are. We'll clean that up in a minute. When I put the wire through here, it'll be locked down a little bit more, and it'll be easier for me to work with. I'm gonna put that one through there. Through there. I'm gonna go over to here. I'm gonna be the next one down in line. This is the method that I use in order to build circuit boards. I use these wire wrap wires, and then I use a one-sided perforated prototyping board. If I need a header that's got a lot of strength, then I can put a header through the opposite direction. So it comes to the other side of the board, and then the soldered pins provide it with like an anchor. Or if I'm working with surface mount, because these are square pins, I've got a nice clean line that I can solder a component across. An 0805, which is the second smaller of surface mount sizes, is perfectly suited for this sort of board. It's just the right size so that you can work with stuff. So I can throw down surface mount LEDs all day and make all these wonderful little test boards. Because remember, this is always just a little test board. This isn't the final implementation necessarily. And then you do the red-green quote. You go, unless it works, in which case it's permanent, which is very much true in this sort of thing. Very, very much true. Okay, so next we have LIN bus, and I have absolutely no idea which one is TX and RX. I think they're labeled on this over here. And I've also got them labeled when I declare the pins, but I think what I can do is just drop right here and just do TX on that and then RX on the other one. So I can just grab it midline. I mean, I could put it elsewhere, but if I want it to be visible, like visibly, this pin is connecting to a blue wire, and so I can follow that a little bit easier. I don't have that many colors of wire wrap wire, so ASS, keep it simple, stupid. Keep it stupid simple. All right, just solder that down real quick. The icrometer. Oh, we're a little out of focus. Hold on. Sorry, bad production, bad production. Wee-oo. There you go. Boy, I melted a little bit of a DigiKey bag. It smells waxy. Yeah, get that off of the iron. You wish this thing had the dip version of the chips? No way, this is the way to do it. It's great. What's up, Turts? What the deuce? Oh, it came out. All right. Let's see. So we're doing one right here, and then the other one's going to be right next to it. Doesn't really matter all that much, just as long as I can see what's going where. There's plenty of room on this board. I mean, that's the whole purpose of spreading out. I have trouble spreading out when I'm building electronics like this. And that's the whole purpose of a board like this, is to spread out. I mean, the surface mount stuff, whatever. You know, you got to be comfortable working with both. And I actually prefer it on these boards. All right, we'll come back with a microscope and clean it up. That's pretty sloppy what I just did there. Also, you can't see the wire color. What the hell? Hold on. Oh, I totally screwed that up. Totally screwed it up. Totally screwed it up. Everything is terrible and I messed it all up. Okay. Let's do one of these. Bend the jacket. And that way the jacket is visible on this side. And I'll just bend the end here a little bit. There's a fellow on Twitter, and I think TurboNat is the person who knows who I'm talking about, who's been building these open air circuits, and they're made to look like pieces of space hardware. They're really cool, but it's using a lot of similar methods to what I'm doing here in bending sort of the wire in order to cater to the mechanical layout. That's kind of on there. I'm not proud of it, but it's there. All right, and then this one goes next to purple. Yeah, that's the one. Sorry, I'm not facing the monitor for once. I'm actually working in the real world. It's weird, right? Very strange doing stuff in meat space. You know, there's a little stripping tool that comes with the wire wrap accessory, the Radio Shack wire wrapping thing. I should probably grab that, because then I could just get in there and pop off. Whatever. Whatever. All right, last wire before we have to check everything over and solder it all down officially. So strip that, go to the jacket, bend it over at the jacket, clip that a little bit tighter. Yep. And then we're going right here, right next to the blue wire. So these two are associated with one another. This is where we jump under the board and over. So all I need to do, hook this one up to there. Yeah. Yes. I'll just go crosswise. Damn it! The weight of the board pulled it through the wire. Son of a bitch. All right, hold on. Sanity is the playground of the unimaginative, I suppose. Well, it's nice to have sanity for when you're trying insane stuff so that you can contextualize it. I was just sitting at my desk for 8 hours. Meat space feels weird. What, it's like taking off that VR headset? Some of you, those of you who know people or have VR setups yourselves, that feeling is very strange. It's sort of like a little bit of disappointment that you're in the real world, especially with the Valve VR games, because those are particularly immersive. You kind of take it off and you're like, oh man. Knowing people. All right, I'm getting presumptuous, I know. Like, yeah, you guys remember, like, you know when you're happy and chat's like, wow, way to assume. Like, ugh. Talking about the sun as if. Who does he think he is? All right, so there's all of our lines. Bend those down like that. Now we got to attach them all. That's going to be a little fiddly, but it'll be aided by the microscope. I don't know. It's not the best setup that I've ever done, but I think it'll work. What's up, Pyro? Is VR gaming really that immersive? Yeah, I mean, you know, it's not like the graphics are going to fool anybody, but the interactivity layer, like being able to instantly sort of move around and have a sense of your limbs in that space and a sense of, you know, being in that space, and then removing it, there is a little bit of kind of like a coming out of the water kind of thing. You're just kind of like, wow, weird. Because it does a lot of good stuff to fool your senses. I had friends who were basically coming into trying out VR with a very skeptical perspective. You know, the last VR that they had done was probably that Sega thing that clips onto your shoulder. And so they put on the headset fully expecting to have to like humor me and like, you know, coddle me through how much they hate it. And they were blown away by how well it worked. Yeah, I think the cell phone VR, it's probably come a long way, but at first the cell phone VR stuff, I haven't tried any of it actually, to be honest, so I don't really have a good perspective on that. But what I do, I had a Vive, yeah, it in spite of the lack of graphical acuity, it was extremely immersive in what it did, because it allowed you to kind of like, I don't know, you just had everything kind of worked the way that it should, you know? This is actually going to be kind of tough to solder, all things considered. I need my tweezers, my hands away from hands. And then I think what I need to do, I need to pre-tin these so that they solder down a little bit easier. So I'm going to lift them all up. Yeah, I don't know about the heavy like force feedback, you know, like the glove or whatever that thing is, where it has resistive force feedback on like mechanically. I don't know about that stuff, but I mean the buzzing that it does give you for like the thumb pads and stuff, you know, that's okay. But like being able to just like kind of be in the space is very interesting. And I haven't tried a lot of like a whole broad range of VR applications. I need to try some more stuff. I wanted to get it working with Fusion 360 so that I could actually like play around with the stuff that I'm like building. But in order to do that, you have to make like a whole game engine. And I don't see a lot of people really exploring that, which is disappointing to me because I think it would be a lot of fun to be able to do CAD in VR. Isn't much stuff to do unless you do racing sims. For me, it's just having the whole hullabaloo. Like, you got to go through all of it in order to get it set up. And I think one of the big things that I'm going to do in the near future when I get it up again is, I was going to talk about ED. When I get it up again, what I'm going to do is I'm going to put down a mat so that I have a feedback system by which I know when I'm wandering out of the play area, because otherwise I'm going to end up putting my fucking face into an end mill. I don't have what Djibouti Show has, which is like a blank room full of foam padding. Louis raided the other day. That was cool. I was super excited to see Lou doing stuff. I think he's been doing a lot of retro stuff. Actually, he's probably the one to talk to about GDQ. Having to reach behind the PC to plug it in. Ah, you got to work on that. The breakaway connector is a great little front connector. What? DP in the front? No, DP happens on both. Wait, what are we talking about? No, but the breakaway connector is a great place to, you know, just, you can just put it there. My only disappointment is in the index. Yeah, not the Vive. The index is cable is $130, and it goes bad because they put too many things in it, and it flexes, believe it or not, that cable flexes, and so they just go bad. They just go bad. And so you're out $130. I mean, I was lucky that they comped me the cable that I had to replace mine with. Valve can be very nice in customer service. I sent them a letter that was like, what the fuck? I spent like $1,000 on this thing. This sucks. And then I went and I bought the cable, and then they refunded it, which was very nice of them. They didn't have to do that, but they did. So credit where credit's due. At least they're kind of nice. But you know, we went through all this troubleshooting so that they could tell me, nope, got to spend $130. Here you go. Bye. And I'm like, what the fuck? So that's kind of bullshit. Jeez, I'm trying to get this to solder properly. Oh, whatever, it's close enough. As long as it doesn't make any connection to ground, which it doesn't look like it'll do. It's a little bit bulbous. I don't like the size of it like that, but that is connected. So, all right, there's our diagnostic header. Jesus, that was easy. Only took me an hour. So now I have connections to everything I need. My PC's been wrong way around for years. Yeah, a lot of people do that. What I did in the past was I just clamped the breakaway connector where I could reach it. So I was using the breakaway connector as the regular connector. I don't like that breakaway connector. I don't think that's a good connection. It's a lot of pins and not a lot of real estate. What I think, and what I would love to try one day, if we ever get ourselves into that situation again, we were this close to trying to do it as a project, is to make an adapter for the headset, what allows you to use a USB-C cable, because a proper USB-C cable can take 144 hertz full display port, a full USB 3.0, and 12 volts at the appropriate amperage. So what we would need to do is create an adapter for, probably for the back of the PC. I'm not too certain about that, whether or not the PC would be able to do that. Personally, the graphics card that I just got has a USB-C connector on it. I'm not sure if it would be able to handle it, But the whole point is the USB-C cable itself, a lot cheaper than $130, especially at a decent length. So to get that, to be able to take all of the signals back and forth, make an adapter for the headset, make a breakout cable that goes to the PC. I'm wondering if that's something that can be done. It would take a little bit, not a ton of engineering, but it'd take a little bit of engineering. You have to figure out what connector they're using in the headset. That's probably already known, considering that it's been out for more than a year. More than a year. All right, let me clean. There's like a giant magnet on the back of this thing, so it finds anything metal. Yeah, how do you get to the CD-ROM drive, Gonad? That's a good question. Where do the diskettes go? Where am I putting this floppy? Is a different question that you ask at Gonad's house. You don't want to know. You don't want to know. The floppy drives are in their own room. They're in their own room, and it's horrible. I've seen things. I've seen things that one cannot just unsee. Turbo Nad, aka Flatulent Gonad, aka ChongMcBong, aka any of those other names, is also somewhat known for the Flopotron, floppy droid. His big old organ. That needs a little context. Hold on a minute. Hold on a minute. He made an organ. One room of his place is an organ, what is made entirely out of floppy disk drives. And it is a thing to behold. All right, so let's get this plugged in as best we can. Let's get this plugged in. I don't know why when I'm working on projects like this, I start doing a Crendor. I'm like, all right, let's get this going here. We'll get all these things plugged in. This is what I'm talking about. This is why I'm not able to watch content creators share my own type of content, is because I will just take on traits from them. It's a bad habit. It's a bad habit to have when you're a content creator, which I guess I technically am. I don't know if I'd fully recognize myself as such. I can sit on the council, but I won't be a Jedi Master. All right, let's get this whole thing back in. These two plugs, right? It's absurd. It's unfair. What is this thing actually for? Did you miss the entire explanation of what we're doing? I'm having trouble with the LIN bus right now, which we've had before in the past. The tuning, the timing of the tuning of the LIN bus stuff is off. And so this little header is going to allow me to plug an oscilloscope into this thing much more easily than before. Before I had to use little clips in order to clip in to the circuit board. This circuit board is just like a little add-on to the top of this Granite Devices controller. And what it's allowing me to do is a whole bunch of digital tasks in addition to making a 12-volt LIN bus system part of the entire ensemble here. So this is sort of like, if you're building a pit, if you're building a sim racing setup and you want to use like real car parts, I'm not a great example because everything over here is kind of like crazy. Everything here is just kind of neat, like weird and very much catered to my own needs. I have a steering wheel, and actually it's not uncommon to have a steering wheel that speaks LIN bus. So what I've done is I've created my own LIN bus system, and because we couldn't find programs for the Arduino that utilize LIN to the degree that we wanted them, to the degree that we needed them to, I made my own. We bit-banged it. And so in doing so, made a nice little 3-wire digital system that allowed us to power and get data back from accessories. So what I was able to do, make a bunch of little accessory circuit boards of our own design that spoke this language. This is actually something that Hackaday was like, yeah, look, you can use it. It's so cheap. You can utilize the LIN bus on your own personal projects. And nobody did, right? Nobody did except for me, because I was faced with the reality of having to do it with no choice, because our steering wheel speak of the language. We couldn't replace the steering wheel electronics because there was not a dire need for us to, and the multiplexing of the buttons confused me. They have like weird button banks and stuff, the way the Germans decided to multiplex the buttons on that thing. So I decided to just let it run itself, and we just pull it through the LIN bus. And all we had to do was make a little brute forcer that tried out all 12 LIN bus addresses. In terms of like security, LIN bus is terrible. There's like 5 device, I'm exaggerating. There's like maybe like 100 device addresses that you can use, which is not a lot. So basically LIN bus is not meant to have a lot of stuff on it. And so what we were able to do is very quickly brute force and figure out which ones of the addresses were throwing us back data. We looked at that data and we found the parts of that data that change when you push a button. Easy peasy lemon squeezy. All that our device had to do then was decode that packet and then turn it into button pushes. Well, we ran out of buttons. And so the only way that we were able to put more buttons into the system is by using the wireless wheel module. And I didn't want to have a Bluetooth accessory on this thing, and I didn't want to have to go through all the trouble to buy the expensive wireless wheel. So what I did is I bought the expensive wireless wheel module, and then we reverse engineered it. And we were able to figure out exactly how it worked. And through the magic of struggling until I was ready to cry, we had about 75 streams where we were programming the Arduino, and everybody got sick of my channel, and everyone decided to unsub. And so through the magic of unsubbing and boring your audience, I was able to actually reverse engineer the SI Labs Bluetooth module insofar as this thing knows it exists. So this thing is able to talk to our microcontroller, and as far as it knows, it has registered a wireless Bluetooth module to do over-the-air communications with a bunch of buttons. So we got there, we got the LIN bus, we got both of those systems, we put them all into one microcontroller, hooked it all up to the hardware, and it works. It works insofar as, and that's always a bad way to have to start explaining something, it works insofar as we are able to push a button, and that button is acknowledged as being pushed by the base station. The only problem is, you got to jam the button a couple times, or when you hold it down, a bunch of buttons get hit at once. Something's wrong. Something's wrong with the timing. And that's due to the fact that the structure of the program has changed, the polling of the different addresses has changed, the timing of the polling of the addresses has changed, the polling of the timing of the addresses on the system on the bus line has changed, the bus line on the system of the polling of the addresses of the bus line of the... Anyway, yeah, through sheer determination and dumb, we were able to get to the end of this. So we're at the end of this. We're at the point where I need to do some timing manipulation stuff in order to get this thing running properly. And so in order to fully utilize all of the I am adding headers that will allow me to observe what's going on the serial addresses, or sorry, on the serial lines directly. So all that, because the last time we did this, I had clips on this side of the board and they slipped, and we ended up almost blowing up a wire, because that shit happens. So I need actually 4 of these. Where did I have these? Where do these come from? These are nice, because these are nice because I can clip to them. Because I can just do like one of these, and one of these for ground, and one of these for the signal. I just need one more for the what do you call it? For the pulse. For the pulse. So this is where the rubber meets the road, chat. If you guys were bored before, just you wait. No, if you guys were bored before, we're actually going to start working with stuff now. So it's actually going to get a little bit different. I almost said it's going to get fun and exciting, but that would be a lie. That would be a bold-faced lie. No, now we're actually going to work with the hardware a little bit, which is the part I like. Here's one. Found one. I don't remember making these, but I'm glad I did. Lie to us in italics. How do you speak in italics? Ah, there it is. There's the dentist drill again. Oh, no. I don't know what's going on outside, but it's like and you guys more than likely cannot hear it because that frequency, I know I'm filtering out through my microphone. I use a lapel mic, and I use a lot of filters on it. I use a compressor and a filter, because you have to. You have to with a lapel mic, because otherwise I'd like scratch. I ran it without filters, and I was able to take 2 beard hairs, pictured below, and go like this, and I could hear like so all the filtration I put on the microphone is very necessary. But I'm hoping that that filtration keeps you guys from having to hear what I'm hearing right now, because it feels like my inner voice is screaming in gerbil. It's just, it sounds like there's a dentist next door. I think it's power washing. I think. I don't know what the hell people are power washing right now and why it isn't a war crime, but here we are. Yeah, this would be my Farnsworth box. All right, let's get this whole thing hooked up. So I gotta get everybody over here. These just stay over there. These probe hats, by the way, if you work with electrical engineers or just engineers in general, if they're, I can't stress enough how valuable these things are. These things are to be coddled and protected at all times, because engineers take these things off and they forget where they are and they get kicked off the desk, and then they go into oblivion, right? Or they'll take them back to their desk and put it in their drawer. And it's like, why would you do that? I need this. I wouldn't be able to hear it over the tinnitus anyway. By the way, anybody who calls it tinnitus, you can put on those glasses and let the buck teeth fly and go, actually, it's tinnitus. It's not an itis. Itis is a different medical designation. Tinnitus. Yeah, those little, the probe hats they're very important when you need them. And when you don't, for some reason, freaking animals will just discard them. They'll just throw them by the wayside. So they are to be protected at all costs. Yeah, that would be a good thing to have. Just like a little plastic clip kind of thing. A little tether. I don't know. Probably be kind of annoying to have a tether if you're using because if you're using the probe like this, and you've got a separate ground hooked up and you're using this specifically to poke stuff, or if you're using this with a little spring that goes on there in order to give it a little ground pin, then having other stuff dangling off of it is probably not great. You probably wouldn't want that. Oh, that's the wrong thing. What am I doing? So we want channel 1 to be TX or RX. We just got to make sure that wherever the metal of these things flies, it's not anywhere near high voltage. And then somebody pushes up their glasses and goes, actually, 48 volts is not high voltage, brother. High voltage is designated over 300. And I'm like, shut up. Because it's high enough voltage for me. Oh my God, it sounds like a fucking dentist moved in next door. We got a back alley dentist in the neighborhood now, I guess. That's at least what it sounds like. Now these will be noisy as hell because they're surrounding a bunch of wires that are taking signals in and out. I've jacketed things as much as I can, but at the resolution that we're looking at things, noise isn't going to be too big of a deal. So actually, all this stuff can just go like that. And then we've got our microcontroller, and we'll plug that in a minute. Once we establish that we can communicate with everything, we'll be able to plug in the microcontroller and control it. Okay, so here we go. That's pretty good, right? Let's get our scope adjusted. So to adjust the scope, a lot of people will start at a position of auto. I don't know. I don't think we really need to do that. We're basically just looking to lock the signals flying around so that we can see that stuff is going on. So we have 2 volts and 5 volts on our two probes right now. It's going to be kind of hard for you guys to see. I have trouble capturing the scope operations on this stream. One day I'll be able to afford the model up from this one. It's about $600, which, I mean, I spent more on a mixer, so I really should have gotten a new scope by now. But the step up from this one has an HDMI output. I'll have to look into that. I'll have to see what other scopes are available if I want to keep with Rygal. Rygal I have some kinship with because Rygal has this model of scope, the 1054Z, which is hackable, and it's very openly hackable. Because if you're buying a scope in order to write documentation and stuff with incredible accuracy, you don't care about spending the extra money on the accessories that you need, and you will send the scope out to get calibrated. But if you're like me and you're doing hobby stuff, you do not care about the calibration of the scope. Hacking it to have all the extra features, regardless of whether or not it's tuned to have them, is not that big of a deal to you. And the company will never notice whether or not you've given them that revenue. So Rygal has all but ships these scopes now hacked. They just don't care. And in doing so, they have pretty much cornered the market on affordable 4-channel oscilloscopes that can get up to a decent resolution. So this is like a maybe $500, $400 and something for this scope, and it has become a staple. So I love Rygal. So if I'm getting a step up from this scope, I kind of want to get Rygal. Now I've been using Tektronix scopes since I've been in diapers, but I don't know. Rygal has done some good for the hobby community, and I like them a lot. Okay, so channel 3 is our new channel. And this one, we want our trigger to be off of. Now, this is currently at 1 volt, so it'd probably be really obnoxious. So I'm going to turn that to 2. Whoa! Where is this? Why are you so noisy? Oh, coupling is AC. Yeah, we want DC coupling. That didn't help. Why is it so gross? Bandwidth limit off, probe 1x invert off, volts div, course unit volt. 200 millivolts. Oh, I went in the wrong direction. I always do that. So we'll put that up to 2 volts. These lights produce a lot of noise. You'll be able to kind of see it if we have to get really into the signaling, but usually 2 volts is about right. What is R1 doing on? Oh, is that trigger? Trigger menu. RS232. Let's just make it a pulse. Well, we'll just do edge for now because we're looking for a very quick pulse. We don't want it to do any more post-processing on the trigger because it's not gonna have a lot of time to do anything. And then let's take off reference. We don't need reference. Math we don't need. We don't need our decoders anymore. Now that we have that $14 hold on. That $14 logic analyzer, we don't need decoders. We don't need decoders. Sorry, I'm finding it very difficult to think because of this noise that I have to deal with. You too would be distracted if you had a dentist's drill up one of your nostrils. I don't know why somebody feels the need to run a 10 billion RPM drill today, but I think it's a pressure washer that I'm listening to. And it's not a great soundtrack. I'm not into this kind of music. Turn off the cursors. Kind of getting rid of all of the busyness on our display right now. All right, I gotta use the bathroom, and maybe I gotta go shoot some guy. This fucking noise is like, I don't know if you guys can fathom it. It's like when a certain streamer that I watch complains about a dog barking, but you can't hear shit. I think I heard it on headphones once, but yeah, it's like that. It's like hearing voices and nobody else believes that you can hear the voices, even though you can hear the voices because they're right there. Why can't you hear you guys should be hearing what I'm hearing. Somebody's saying something. No, so I'm gonna go use the bathroom. I'll be back in like 2 minutes, less than a minute. You guys get a BRB. And then I'll just put this on so that you know audio still works. Yeah. Here, I'm gonna scroll down so that you can see it's Zelkovich music. This is my buddy Julian. We're gonna try to get him in here on the show soon, with or without a good excuse to. I mean, we've got an idea of like a simple little project that we could probably do, but we don't need that. I might just get him in here just for fun, just so you can just tool around on a weekend and maybe have you guys come on in tow. So. And he can just play his set, you know, I don't care. But anyway, I have to pee-pee. I'll be right back. Distant Cacophony, thank you for the raid. I was going to the potty, if that's okay with you guys. I still am. No, wait, no, I'm back. How you guys doing? So we've been working on my sim setup, and I'll give you guys an intro to that in just a second here. You guys can hear me, right? Yeah, okay, good. Oh, hopefully I'm not crackling. I see myself going into the red there. Yeah, I'm still going to the bath. No, I'm back. All right, here's the deal. Welcome to my shop. This is where I mop daintily. This is Zelkovich music, by the way, that I'm playing. This is a buddy of mine. Hey, Uncle Phil. Uncle Phil subbing for a 12-month streak. Thank you, Uncle Phil. Yeah, if you guys didn't, those of you who are from my channel or are from Distant Cacophony as well, with a 13-month. How you guys doing? Those of you that have been wandering into my channel today for Sharts and Gargles and the project that we're working on, you guys should check out Distant Cacophony. She does some great streams. I have lurked there in the past. This is Zelkovich music. This is my buddy Julian. We're gonna try to get him in on the show soon again. Usually when he's in here, we bicker like an old married couple, but he's a good friend of mine for a long time. He does a lot of synthesizer stuff now, and a lot of stuff that's built in like wooden enclosures and stuff. It's a lot of really cool stuff that he does. He has been, you know, school's out for the summer, and so he's looking to hang out a little bit. So I would love to get him in here. I don't think we need a project for him to work on. Let me get rid of BRB. Bop, bop. This is a very ambient track from him, but let's fade him out. There's like somebody's power washing, I think, in the background, and I've got like a dentist drill noise in my ear, and it's so distracting to me right now. So anyway, welcome raiders to my shop. This is Twitch TV Oh Bother. I work on stuff in meat space. I work on actual like physical stuff. I like to keep a little bit like within the purview of gaming, but the main project here, which we haven't worked on for like a year, is called Burn the Subs. It's this giant honk of wood that's bolted up against my wall. That wall is going to contain the names of people who sub to this channel. Now, we've had two boards in the past. They're actually framing the back of my desk. It is an XY table that's powered by a Raspberry Pi with, it's going to be a Clipper system now, but it used to be something called Gerbil, GRBL. It's something that controls XY tables, and a Raspberry Pi with a bunch of Python on it gets into Twitch. It gets its tendrils into Twitch and it extracts all the data from you guys who sub to the channel, turns it into code, streams it over to the machine, and then I, like a Muppet, I come to life and I go over there and I move the camera, and then we film the name being burnt onto the wood. So in the normal purview of projects around here, if it doesn't scare you, it's not worth doing. And so the stuff that I've done that scared me about this project is that it's a live edge board. We need to plot the edges of the board and stuff like that. So we're going to get into that soon, but I've been on a big push to finish this thing. Now that's my camera. That's the desk camera. This over here, right here, if you're familiar with what you're looking at, you're far too gone for me to even save at this point. No, this thing right here is a Granite Devices simucube direct drive steering wheel controller hooked up to some kind of a bastardization of a perforated prototyping board that's communicating with a 3-phase industrial servo motor. There's a 2-power. It's got 2 power. It's a 2-horsepower Mitsubishi servo with a custom slip ring that we designed ourselves. It's just like an infinite connection. And then a Mercedes S-Class steering wheel on it. Don't be fooled. That's just an airbag cover that I happen to have sitting around. So I'm kind of a car guy. This Mercedes S-Class steering wheel has a bunch of buttons on it, right? How much force does it put out? I measured, and it's a little bit more than an F1 car in just sort of idle driving. It's not like an F1 car in terms of cornering, but when this thing gets to lock, I have to put a little bit of muscle into it in order to move it against its will. And then I at some point, I'll buy the alternative motor controller card that can put out a little bit more current. But for right now, I don't really need it. Over there is the old shifter that was hooked up to the system. This thing right here is a it's an E46 M3 Steptronic shifter. That is a digital shifter. It's all plastic and springs. It feels great. Problem is, I'm not really good at rally shifting. I didn't know which direction would be up and which direction would be shift down. I didn't know what direction was what, right? When we did my summer car and I got first place in the junior rally, I have, on the other side of this big setup right here, I have actual BMW pedals. Actual pedals out of an actual, it's like an E92 or something like that. You can get them on eBay for real cheap. Yeah, I sent Rabaz a picture of the trophy, and his initial response was "eat my ass." So I guess I did well. Then we went on Thingiverse and we found an 8-speed shifter. Now all of these devices speak what's called the LIN bus, which is the local interconnect network. It's a sort of a Euro consortium type of digital signaling system. We're actually tuning that today, even though we've figured it out many times in the past. We've figured out exactly how that works. What we're trying to do is tune up these 3 devices, not individually. We're tuning up the thing that speaks to these 3 devices so that they can respond digitally to our device over here. And the project for the past month was to add more buttons to this system by faking out being a Bluetooth module. And that sounds weird and difficult, and it is. And it was. And it wasn't entirely necessary, but it kind of was, because we needed more buttons, and instead it was like the only way to do it was to buy the wireless wheel module, and I wasn't about to go and buy the wireless wheel module. So I bought the wireless wheel module, and we reverse engineered how it worked, and got it up and running in the system. So now all that stuff works. It's just we need to take it that last little bit. And so what we did is we just added a pin header on this thing so that I could plug all these probes in there. Because last time we plugged the probes in, the 48-volt power supply had something to say about that. We were over here on this side of the board, and one of the things fell off, and it shorted out, and it almost created a fire. I almost had a fire. Ugh, I had to take a big sip of water. I've been coughing a lot. I had pho for lunch, and all the spices and the warmth of the soup just like dislodged everything that had been sitting in my sinuses. I feel great. I feel like my head is a pound lighter, but at the same time, it means I'm coughing a lot and I'm a little raspy. So, whew. Okay. So what we've done is we've set up the oscilloscope, a thermal event. Yeah, we set up the oscilloscope so that I'm plugged into the LIN bus in and out and an additional pin. So we need to make sure that we're implementing that. We need to make sure that that works within our system. I can go to the new programming view, but I'm gonna have to move this. This is gonna get real weird for a second. Okay. So let's see. We don't need this stuff anymore. We don't need this stuff. We've all figured this all out. I don't need any of this anymore. Haha, that feels good to close. It feels good to close all that. All right, so here's our program. And this is like, oh God, how many lines of code have we gotten up to now? 225, 85, 116. Oh God, it's so much code. 429, 630, 188. I tried to use the tabs to organize it. 482. So that's a couple thousand. I think we're over 2,000 lines of code, right? That's like 5,000, 6,000, 7,000 lines of code. So in these 8,000 lines of code, I have 9,000 lines of code. And I've made some changes. I've actually added if-defs to these things in order to have the serial printouts meaningful again in my 11,000 lines of code. All right, so one thing that I want to enable here is actually the pin that allows me to troubleshoot. So up in my giant block of defines, I have digipin and digipin num. And actually, to be honest, I probably could have made those into one thing. Because if defs look to see if the variable, like if that name is defined, if I have the name defined and I give it a number, I think I can just have one variable there. But this is all kind of new to me. Anything coding, by the way, anything coding for me is like new. I'm not all that terribly skilled at this kind of stuff. Yeah, I've written 16,000 lines of code for this program on Twitch. No, all the if-defs I did on my own. That was a lot of cutting and pasting. I know people who can actually code are going to just shit their pants and start screaming as soon as they see how they're like, this is how you live. Like, this is the kind of code that you're putting together. But yeah, you know, hey, whatever. I gotta remain entertaining for the people who are here from gaming streams. So thank you for the raid, DistantCacophony. Anyway, pin number 6 we have designated as our little tiny pulse in the LIN bus stuff. Now, we've been through the ringer with the LIN bus. We have, it's the squalor core coding. Oh my God, I would die. I would die. I've got to do a certain amount of organization. People that can actually code forgot all the shit code they wrote in the past. After coming over here from doing my serial programming to get the module, the fake module working, looking back at the LIN bus stuff, I want to rewrite the whole thing. I'm going to burp on stream. I'm not going to rewrite my code for the old stuff. I'm really tempted to, though. I'm really, really tempted to do that. But anyway, so yeah, like here's like notes for the analog adjustment and stuff like that. There are better ways to do all of this stuff. Here, let me move that over just a little bit so you guys can see it. There are better ways to do all this stuff. Been coding for over 30 years. If the code works, who should care what it looks like? I have a specific point of interest on me, or on that point. I have a specific thing. No, it does matter. Just working isn't good enough, because it's something like this. I have to come back to it now and adjust it in order to get it to work properly. And I don't know why. Because we had the LIN bus stuff was on lockdown. So LIN bus from the LIN consortium, which is something that maybe one day I'll be on. I'll be on the LIN consortium. Yes, hello, it's me, the prestigious. They probably meet in at the bottom of a temple, like in the basement, and like do ritualistic shit in robes in order to figure out what these digital protocols should be like. So anyway, this LIN bus stuff, the way it works is that you have a, for lack of better terminology, master and slaves, right? We've decided in some cases that we would be using sub and dom as a replacement for master and slave. But yeah, anyway, so you have the bus master, which is the thing, basically the lecturer, the thing that's giving the talk to everybody else all at once. Everybody shares a main communication line, so you can think of it like somebody sitting at the front of a lecture hall. And so you have a bunch of devices what are supposed to be given instructions or giving back data to the main thing that's running the whole show. So the main thing that's running the whole show will hold a speaker line down. So I don't know, squelching the megaphone. It'll hold that speaker line down for a certain amount of time, and then everybody starts paying attention. Then there's a series of pulses to give everybody a sense of what the timing looks like. So they squelch the mic a couple times, and everybody goes, all right, I know when to listen. Then they ask for a specific address, and if that address is asked for properly, everybody else fucks off, and the one device pays attention to what needs to be done next. And then it goes, here's what you need to do. I need to know what temperature it is. And then the other device takes a millisecond to calculate what the packets should look like and immediately responds with that data. Or goes off and does its thing and responds asynchronously. That's all within the protocol, but for us, we're within the space of it taking like a millisecond to figure out what the state of the buttons are and then poop back out a packet. Microcontrollers work very quickly at the tasks that they're given. So we need to take a look at the timings of these things. We need to take a look at them on the oscilloscope because that's going to give us a good idea of where it's all going wrong. When I push a button down, the button works, right? Which means that our whole system works, but it'll then start, the button will start clicking the buttons next to it. So something is a little hinky about our timing. The amount of shit code that most companies run on is insane, but it's so baked in they would have to rewrite it. Cars are running into that problem nowadays right now. The modern automotive consists of a lot. It's basically a totem pole of technology, which is a wonderful little phrase that I just can't get over. A totem pole of technology, because the next generation of stuff is stacked onto the previous one. And so you've got extremely old but proven systems. You have old but unproven systems. You have whatever the fuck we were doing in the 90s. And then you have modern systems sitting on top of that, giving you a nice touchscreen display. And so somewhere in there, cough, cough, whatever the fuck we were doing in the 90s, you have an extreme vulnerability to digital attacks. It's insane what people get away with in terms of car hacking when they have cardinal knowledge of the system at hand. When they know exactly what the system looks like, people can get in to your analog brake system through your tire pressure monitoring system by reprogramming nodes, because somebody along the line went, well, we want the technician to be able to scan to see if the tire pressure monitor system is active. So we need a hub that goes between tire pressure monitor and the diagnostic bus. But we also want the diagnostic bus to be able to scan the analog brake systems. So we need something that goes between those two. And those two ideas were off by 20 years. And so this one is extraordinarily vulnerable, and this one is only slight. It's a mess. It's crazy. It's absolutely crazy. Yeah, I was responsible for doing a little research into that stuff for forensics. Where were we? We were on this one. Okay. But again, it requires like cardinal knowledge of the systems at hand. It's not as dire as a lot of researchers would make you think, because those researchers are after grants. They want you scared. 80s OBD paperclip. Yeah, I need to make a paperclip, an oil change paperclip for my my car. I have an I have an E39 BMW station wagon. So I can do the paperclip trip in order to tell it that I've doing an oil change. Okay, so I need to, let's see, we've activated the stuff we need to, right? So my if def diagnostic pin, blah blah blah, high and low for 3 microseconds. So where is that happening? I is 0 to 7. So this is the get bits. I 0 to 7. Yeah, this is exactly where we need it to be, because this is the same problem we had before when we tried to get Linbus working after a little bit of time. Everything kind of drifts out of tuning, right? I bought from some eBay auction. I bought one download off of a Chinese FTP server to get literally every diagnostic program that exists for my generation and previous BMW. Including the manuals, all the maintenance manuals. I have those sitting on a couple laptops that I need to tune up. There, Pilly 5. 97 truck is some extended OBD2 that I haven't figured out yet. Yeah, it's digital. The digital stuff with cars is pretty neat when your car gets old enough that the tools are available more publicly. There were supposedly free downloads for all those programs, but I was never able to really find them. But yeah, with BMWs, they've gone to the point of reverse engineering like all the registers on the ECU, so they know everything about them if you get the right kind. Pretty cool to see. I think I could just throw this code like in there. Oh, man, what was I doing with formatting back then? I was putting spaces after the 4s. This is like double spacing your documents. Weird. Yeah, let's see what we could do here. So let's upload this. I'm gonna plug in the Arduino. We're using a Teensy 3.2, which is an insanely capable Arduino. It is an extremely fast and like capable Arduino. It's by some guy named Paul Stoffergen, who is like my personal hero. He's awesome. He's helped me out with code in the past. He's too busy nowadays. I don't hear from him at all. I'm like nothing to him. Return my emails. No, he's cool. He makes the Teensy line of microcontrollers, and they range from powerful to exceedingly mind-blowingly powerful. The 3.2 is like a $20 microcontroller platform. It's for your more hardcore tasks. It's for the stuff that you're really trying to min-max. Or put a lot of code into, or maybe you're just really bad at coding and all of your routines take way too much time, then this would be the microcontroller for you. It is a great starting point for all of your projects, because your projects start out in sort of a condition where you're not trying to optimize anything. You're trying to do a proof of concept. You don't want the overhead of the microcontroller to be what gets in the way. So you use something like this to blink your LED, and then you're like, well, okay, I can blink the LED with that. How can I pare this down if I want to go more professional with the whole project? So yeah. All right. Yeah, back in my day, diagnostics were done by putting a piece of tape over the warning light. All right, so let's upload that. Link to the board, pjrc.com. PJRC. So I don't really have verbose serial prints going on this thing, but what we can do, where are we? We can hook up, we can turn this thing on. Yeah, I mean, that's the way things should be done. It's often not the way things are done. Hold on, I gotta cough 1 sec. Really, to be fair, the old method of doing stuff is what I sort of cut my teeth on, right? The old method of doing stuff was you started off with perforated solderless breadboard. I only use this stuff for like quick projects, or, well, actually I always start with solderless breadboard because this is the best way to go, right? You plug everything into this and you can break it down later. In fact, this is the test setup to get the TX and the RX stuff working properly. That's what we did with this. So that's your first step. Then traditionally, your second step was to go to perforated prototyping board and build something like this. Something that was a little bit more permanent. You could still edit stuff, and then you could plug in, you know, all the stuff you need to. From there, you would design a circuit board, and you would either etch it yourself, well, you would usually etch it yourself, and then prove out your circuit board design, and then you could go to a company external and have them print up your board for like $20 a board. Nowadays, PCBs are $5. You could just spin off a P. You don't need to do this. This step is dead. You could just design this in CAD. If you got a good library going, with all the parts going that you need, you just bop, 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 boop, bop, done. Right? It costs you $20. That's it. And you just have a professional looking project now. I'm so jealous of projects nowadays, even though I'm doing it too. So jealous. Nobody needs to go through all the steps anymore. All right, let's turn this thing on. Oh, no, it's not on. All right, turn it on. Let's see what happens. We're supposed to be polling for Linbus. Oh, I saw something. It's going to take a minute until everything comes up. There we are. There's our buddy. What the fuck? Bud. Buddy. Bud. Hello? Okay. All right, hold on. You got a feedback issue. Okay. Whoa! What, did your phases change? What the fuck? Why are you so unpredictable? There's some weird shit going on with the feedback. I'm gonna turn it off and on again. This happens periodically. I don't know why this thing has been getting a little weird. Now, there are safeties in place for all this stuff. It's just, I think maybe some of the... This keeps getting loose. I don't know how. That was really weird. Let's, do one of these. One of these. Do one of these. Do one of these. And we can see the LIN bus stuff at least responding nicely. Oh, it's actually still polling LIN bus. You can still see it polling LIN bus because the microcontroller doesn't know what's going on. Let's reset that independently. Let's try again. That little snap that it does really concerns me. Oh boy, that's not good. Why are you doing this now? Open palm. Don't get your fingers caught in there. It's like a noise thing. It's like completely locked down. What the fuck? Hold on, one sec. Bud? Bud, you doing okay? Yeah, something's inverted. I can feel it like locking into positions. Oh, that's really weird. I think the encoder's messed up. All of our encoder lines seem to be on. Those are connected okay. Any other interaction between the two boards? I mean, our stuff shouldn't be interacting with the rest of this. It's just the encoder lines. Just poking around a little bit. Yeah, it's not smooth anymore. It's like, something's weird. Yeah, Cannibal, we got all of the Bluetooth emulating module stuff working. And now that's the only part that works for some reason today. We'll have to take a look at what the hell's going on there in a second. We're trying to do the other part of it. It shouldn't like for all intensive purposes, for the past couple months of testing, every time we turn it on, everything's been totally fine. The wheel spins nicely from lock to lock, and when it locks, it stops you from spinning the wheel. What's happening right now is there's some kind of a feedback. The center spring isn't reacting properly, and then when I move it a certain amount, it feels like a ball detent. It like jumps over to the next piece. I think maybe the encoder isn't properly giving it results. I think maybe the encoder's not connected properly. And that could just be a wear and tear thing. That could just be the cable getting weird. So I am not going to link any of my fingers into this thing because it is a powerful motor. But I'm curious as to what's going on here. Like if we lost connection with something. I hope it's not one of these cables acting up. You should be okay. Yeah, I don't know why it's doing this lately. Weird. All right, well, that's not the task. That's not what we're looking at. We'll burn that bridge when we get to it. What we've got over here on the scope is a full amount of data. It's way more complicated than that. It's way more complicated than just a PID. It's an entire force feedback system. There's a lot going on. Already seen one YouTuber injure himself with a direct drive wheel. Well, you know, while that's a possibility, I'm a little better than that. What a multidisciplinary complex science fair. It's more like an elevator full of a bunch of different disciplines. And it's one of those elevators where like the doors are a mirror. They're like a mirrored surface, and the architecture, the architect never really thought of that. And so everybody is kind of forced to stare at each other, and it's just really, really awkward. By the way, I used to work for an architectural engineering firm in Philadelphia with a prestigious name, and that's exactly what their elevator was like. Their elevator had a brass mirrored surface. It was part of the Federal Bank of Philadelphia, and you get through the metal detectors and stuff in the morning, and then you get to stare at your coworkers awkwardly. It was kind of amazing. All right, so in terms of locking down the signal, this is a little bit more stable. Now we can set this to trigger on a certain point, and we might need to do that. We might need to give it a little bit of information. Let me try to get you guys a little closer so you can see what's going on. It's hard to see. It's hard to see the contrast between the colors and everything on this. Let me move this light. I'll give you a little bit better of an idea, and then of course I need to focus the camera. Hard to see when stuff is fluttering around like this, and it'll stabilize itself once I get the trigger right. So let's look instead at, what are we going to look at? Let's look at a certain amount of blank with a certain amount of ups after that. So we want to look for a pulse, and we want it to go greater than, well, this is already done quite a bit to stabilize it, although we're still unstable because these are looking too variable. These are looking too variable. I want to lock this thing down, and I could change the nature of the serial print. That would help. That would help a lot. But I think what I want to do is take this and just tweak it. This is looking for 60 microseconds. I think we need more because we got 3.82 milliseconds on screen. That's looking a little better. I just don't like that. Now, if I hit a button on the steering wheel without chopping my arm off, you can see right there. Nope. Okay, it's moving around. See that? Oh, we missed it. All right, so let's get rid of the. What do I want to get rid of? I don't know. Hold on. What do we want to get rid of here? How can we stabilize this fully? I'm looking for like a unique beginning of the signal that's not going to change, and the scope is all over the place. If I look at like multiple pulse detection, so if we look at maybe a pattern, channel 3, code is high, low, transition high. I don't know, transition high, sweep. Now, that means the scope is stopped. So if I hit a button, yeah, nothing changes. So that was a single sweep of what's going on. We're triggering off of every time we're looking at a particular pulse. Now, this is coming from the steering wheel over here. And I guess we could use that. Or we could go back to the pattern and see if we get a good pattern. Or sorry, back to the pulse. And then run the scope. And we can do a single trigger. All right, so we're going to zoom out. I'm going to zoom out. We'll do a single trigger, and now we have enough data. So we'll just lock it in place. Now, what I could have shown you in the past is the data changing as I hit the buttons, but I'm a little nervous about getting my hands near that steering wheel right now until I figure out what's going on there. We're looking at this right now. So one of them is transmit and the other's receive, but when it transmits, it also receives. That's what the discrepancy is between these two. One's at 2 volts, the other's at 5 volts. Let's put channel 1 down to 5 volts, just so that's a little smaller on our screen. And we can zoom way in, and we can see where we're getting our 1s and our 0s from. And it seems like we're not quite getting them at the right times, huh? So why is our data wandering so much? Why is our data wandering so much? So in the scheme of the LIN bus, the local interconnect network, here we've got everybody pay attention. Here's your timing information. It's just 5-5. Here's the address, which takes on its own form. It's kind of complicated. And then we've got our data. And this data represents the buttons that are pressed in the steering wheel, among other things. There's like a version number for the steering wheel and stuff like that. There's all kinds of, because if you have like a different Mercedes steering wheel, you can plug it into this car and it'll still work. It's really weird. Even if it's got different features. Brake. These need to be way faster. Wait a minute. These are way too slow. This is where we're... Hold on a minute. Those should be 8. Those are bytes. Those should be 8, right? Should those be 8 or 4? It needs to be way the fuck faster. Oh, is that tomato going live? Yeah, I think that's what that was. Take a look here. So, okay. Bit start to initialize. So we do the bit start, which means we get, or we give timing data because we're the bus master. We're giving timing data, and then we start to output. And when we output, what are we doing? For 0 to 7, I++, we set high-low. Then we delay, and we write the RX pin. What's going on with the buttons right now, though? Are they stable? Oh, hell no. No, they're not. If I hit the button, look at that. That's me holding it down. Doo-doot, doo-doot. Meanwhile, the wheel's getting all twitchy. I don't know why the wheel's getting twitchy. I think the encoder needs to be reversed. Let me try to fix that before everything goes haywire. What was the fix for that when it gets all crazy? Max current is 14 amp. Profile names, I don't know. Hardware setup, 18 amps. USB recovery, don't care. Center spring, 70%. Advanced. Nope, nope. Created a force feedback effect. We don't have any force feedback effects going on. Debug log. I don't know which one reverses the wheel. Or reverses the feedback direction. I think that's like a game thing, right? Well, it doesn't need limit switches. It's a 360 motor. If I had like hardware to make the limits physical, I don't know how I would do that because you need to have multiple turns of the wheel. It's just not something that we can do here. So there are virtual bump stops, and they're determined by the encoder position, but the encoder position, sometimes the directionality gets a little messed up. I don't know. It's like, it's something in the, it's something that the game does. Like in the games, usually I have something where I can invert the direction of feedback. It's just something that kind of gets confused sometimes. Oh, motor, encoder, and center point. No. I don't think I need to do that. I just tried turning it off and on again. But I mean, okay, so one thing we need to do is we need to figure out what's going on with the LIN bus stuff that's coming in. I'm just a little nervous about having this thing sitting next to me if it's going to be so twitchy. Let's see if I just turn it off and on again until it works. Probably should have spun it around too. Well, that seems fine. Nope, not fine. Why are you doing this, stupid thing? I don't think they should, because like my circuit board does not interact with that part of the board, right? Unless I have like unless I had like a header plugged in backwards and that somehow affects it, but I don't think that's the case. Yeah, I know it's upside down in simucube. What if I turn it upside down to be the same orientation as it is in the virtual picture? Try that. I'm looking at this thing like right here to see what it's doing. Does this little back and forth test. Beep boop beep. See, it's not supposed to be doing that. Weird. Then it like fights me with full force because I think it thinks it's going the opposite direction or something. Well, it's also not responding to positional feedback as I move it back and forth. So I think something's wrong. I think something's not connected, or maybe I lost a connection to something, like maybe a wire pulled out. Wire cutter pliers. Okay, let's see here. Hold on. I have the wire, but I was prepared. Up. Unplug it and plug it back in. A lot. These are screws. These are typically, well, in the future, these are going to be set up permanently. These connectors, because this controller will now be on the pedals. That's whatever's going on right here. It's one of these guys. It's this one right there. It's one of the ones that's not connected. It is what it is. It ain't what it ain't. It couldn't get much simpler than just connecting these things again. I don't know why it decided to get all topsy-turvy from my my efforts. This is the one that concerns me because this keeps getting loose. This little collar right here. And what I don't want to have happen is this to twist the wire and break it. Let's check the status of these. Should this go? Well, let's see if I can do that at all. Yeah, that might be part of the problem. Hold on. We gotta double check. Yeah, I can also just disconnect the motor cable. I wanted to get this thing working today, though. That's the problem. Is part of getting it working is not having all of this stuff go wrong. Virtual ground. I don't know. Everything's pretty well grounded, you know. I kind of made sure about that. Everything's got a nice, clean ground, or it should anyway. It should. Maybe it doesn't. Yeah, this thing just constantly loosens up, doesn't it? But I think the problem would be in the encoder somewhere, so I don't know. What could I have done? I could have accidentally bumped a wire. There are not too many wires coming off of this thing. It's a little DB15. Those are all definitely connected. Up here, they look okay, although that one's flexing a little bit. Nobody's loose up here. Nah. Wind bus is all situated. This one's good. Yeah, those seem okay. Probably should have put a little hot glue on those just to stick them. What is that? Oh no, it's just a little piece of debris. This is the most concern I have is inside of this this connector, because this connector, this piece keeps coming loose, and this one is extremely locked in. So what could be happening is that as I connect and disconnect this thing, I am tweaking the line a little bit. But let's just reseat everything, see if it all comes back up. Because this will happen in game, not here, not when I turn the device on. And when this happens in game, there's a way to reverse force feedback and it fixes itself. But there shouldn't be any force feedback. This should all be just internal. Damn it. I think the encoder isn't connecting. Or one line of the encoder isn't connecting, because I mean you can see it's not turning. Whoa, it did kind of turn there. What the fuck is happening? Hello? I mean, there could be a massive ground loop and it's causing all kinds of noise. It might not be the encoder. It might just be like massive amounts of noise on everything. Or maybe I did plug one of these things in backwards and it's causing all kinds of issues. I don't think so though, because all the labels are facing me. That's ground. And we're getting a clean signal digitally. So if there were massive issues with ground, our digital signal would be all over the place. All over the place. What then could it be? Our board doesn't interact with any of the feedback stuff, so our board doesn't interact with this layer, the encoder and stuff, because that's a higher priority. Only you are connected over there. Yeah, there's no problem with those. All those wires are getting a little warm. Because it's like doing all this feedback stuff that we're not seeing. I don't know. I don't know why it decided to go haywire. Yeah, I mean, just following suggestions from chat. I mean, I could just unplug the wheel for now. Because all we're concerned with is the LIN bus right now. And if we can get that working, then we can move on. And diagnose whatever the hell problem just came up right now. See, well, actually, right now, we can just diagnose immediately what's going on, which is that we are sending LIN bus, and our pulses are coming in a weird way. We need to see what that's supposed to look like. So what we're really supposed to do is we are waiting for a certain amount of microseconds, and then we are writing stuff or we're reading stuff. Now, where do we ask for the address? Need to kind of like remind myself about how this thing works. Yeah, see, look at that. The whole motor's heat. Yeah, oh yeah, that's warm. That takes a lot of energy for this motor to actually get warm. That's not good. Something is awry. Strange things are afoot at the Circle K. The controller's getting warm too. Yeah, that's a new one. That hadn't been happening up until now. Up until I removed that circuit board and put it back on. What could I have disturbed? I didn't unplug anything from that. What if I do this? Hold on. What if I do this? There. It does that calmly always, and then beep boop beep. Nope. Nope, that's not it. Stop it. Stop it. Stop it, you silly, you weird thing. Why are you being weird? Stop it. All right, well, I think maybe the encoder isn't, I think maybe one of the encoder lines has gone bad. I'll have to investigate that. For now, though, we have LIN bus stuff to take a look at. So I'm gonna unplug the entire motor and just leave this thing off to the side. Is that, wait, that might not be good. No, it should be connected to something. It needs to be connected, I think. Because if we have just the encoder with no motor hooked up, it's going to be trying to switch the MOSFETs. Is that bad for them? I don't think it is. If it's just trying to switch the phases and nothing is connected. I'm not totally sure. I'm going to leave it plugged in. Well, I mean, the loose... I don't know. I don't know. I don't want to pull this thing apart again, because we did that, and it was a pain in the butt. Get it back together. Although I can get a fingernail in there, so maybe that is the culprit. It could be either of these. This board doesn't affect it in any way, even though we see it behaving differently now. Well, we know this didn't do it, so I'm going to plug these back in. Ah, get off of that. It's all right. We'll figure it out. It'll be something dumb. It'll be something dumb. No doubt in my mind. All right, so what is going down over here? So, what is going down over here? We're looking at the LIN bus. We're looking at a focal point that's right in between. These are supposed to fit within the things that we're communicating. They're not. They're off. This is what I was talking about with the signal wandering. Yes, I believe. I mean, these should be like locked in on the individual parts of the signal, and it looks like they've got weird delays on them. There's like some weird spacing going on, and it's just not really agreeing. Now, how are these supposed to be organized? I think they're supposed to be squished in, right? Let's see here. So if the diagnostic pin, we're setting this thing for 3 microseconds, high and then low, and we're doing it in this loop. So this is get bits. So after we start the bit and we give it the timing, we go to get the bits back out. And so for this loop, we delay a microsecond, which is a microbit plus the rise and fall time. And then we write thingy of I digital read of the RX pin. So we do a digital read of the receive pin at this point, right? So I write this, and then so within this amount of time, right? Okay, here. Here we go. All right. So within the amount of time between this pulse and this pulse, and I know they're barely visible right now. That's just the way this is. Let's see if I can get like a piece of cardboard that I can put on top of that. What do I got? I really don't have anything. I don't have any good cardboard. This is just had trash day. All right. Surgical hand. So we have 1, 2, 3, 4, 5, 6, 7, 8. That should be in here. We're reading way too slowly. That's what's going on. We're reading back the data that's being sent way too slowly. Our half bit is just way too long. Because, I mean, there's like an eternity between this pulse and this pulse. This is the delay 3 microseconds and then wait U-bit plus whatever, and then that's like we'll read like somewhere here, and then the next one comes in and we read somewhere here. It'll all be in the same space somewhere in there. We need to squish this down. That needs to be squished down. And it probably needs to be squished down. All right, so what are we waiting? We're waiting U-bit plus the rise and fall time. Shouldn't that be... Oh, I see. When we bit start, so that's what sets us off. We go off by a certain amount, and then we exist somewhere in the half bit. Rise fall, I guess, is this time. Okay, let's go back to our settings up here. U-bit is 50, 11. When this is 3. Why is it so slow? Half bit should only place us in the center of that. Why is our bit timing so far off? Why is it so far off of where the signal is? Oops, sorry, I'm skipping around tabs. Been working with peppers and just wiped my eyes. Please send help. I'm growing peppers and I don't see anything happening yet. Yeah. Huh? Cables are screwed on the motor. Huh? No, when I add that, that's what this extra delay is, I think. I think that's what's going on. I gotta pick apart my code here. Even if we got rid of those extra delays, that's only tweaking us by a couple microseconds, so that's not really getting us a better signal timing. And also this code worked before. So U-bit is our timing, and that's set at 50. But we're the ones that set that timing. That's the thing. That's the weird thing about this, is that we are the ones that are setting this timing. We are the ones that determine what that bit timing is. We do that right here. So I put my cursors up, and I measure one at each bit. That should be yeah, 250 microsecond pulses. So that's 104, which, you know, my cursors are off by just a little bit. $104, and then our time between, if I take the whole, yeah, let's just take the whole signal over. 104. Yeah, this is about that length. So all the math adds up. We're doing everything the way we should. Our delay is adding. That's in the wrong spot. Should it be U-bit? It should be U-bit minus rise fall time. Because the rise fall time is 3 microseconds for the pulse. Then for 3 microseconds that we're delaying right here. Now, there is time that the Arduino takes to write the up and the down, and I think we measure that to be 3, but that would, I mean, 3 plus delay microseconds, so. Wait a minute, what? Delay microseconds, U-bit minus 3. Delay microseconds, U-bit minus rise fall. What the heck? What am I doing in this code? All right, hold on. Digital read of RX pin, and then we bit write that to thingy. That's the return on the function. So our timings are all over the place, and things are weird. We should be waiting for, in order to write a pulse. What are we doing here? Okay, hold on. I just beeped again. Oh wow, glucose level's like falling. No, I don't want to give insulin. All right. Sequence of events. If we have a rise fall time, then our U-bit should be subtracted by it. Delay microseconds probably shouldn't even be in there. So we go high, low, high, delay, low. Then we have our U-bit minus the rise fall, which should typically equal 0 if we don't have this stuff set, which should probably be a variable that I'd set, but it's whatever. If-def does not mess up timing for digital pins. What's in the if-def, maybe. If-def is it's a signal to the compiler. So we just have to make sure that when we add that 3 microseconds, we're subtracting it from our overall delay. So until we do the loop again, we are doing that. We're delaying for exactly that amount of time, because up here, I have a delay of half of the bit. So I wait half of the bit. And actually, I maybe shouldn't pull that out of here. This should probably be put into here, but you just meant, yeah, what's inside. Yeah, what's inside definitely affects it. That's why we're looking at this thing. I don't know why this was in here. U-bit minus 3 for the delay, and then another delay down here. That doesn't make any sense. And then I'm adding 3 back into U-bit for another delay. It doesn't make, I mean, we're waiting for the next pulse. That's so whatever happened there might have messed it up. Let's upload that. Bop. Let's see what that does. That might fix it. Maybe. Hopefully. We good? We good? We good? I think we good. All right, let's go over to here. Turn it on. See what happens. Of course, the wheel's going to go psycho again. We're just going to wait for all the other serial stuff to come up. There it is. Wiggle, wiggle, wiggle. Stabilize that real quick. And let's just do a single trigger. And I'm going to turn it off so that things don't overheat. I don't know what's going on with that encoder right now. I got to get to the bottom of that. Maybe that's my Sunday project, and next week we get into my summer car. There we go. Look at these reads. That's more like it. That looks more like the data that we should be getting. Good stuff. Now, I don't know whether or not that's synced up to the ones and zeros, but it's definitely, you know, things are fitting within their sort of pulse area, and then they've got the requisite, I think it's a low-high after each, like it's a stop bit, start bit, and then we get into the bits again. Now, the question is, with the cursor where it was before, which I think was there, that should be approximately the same, yes. Okay. I think that might fix it. That might have been it. Because, yeah, here's a 5-5. And then that fits in within there. Might need a little tweaking, but I think that might be it. Yeah, no, we're not talking about that. We're talking about the effects from the stuff inside the if-def. That's what that other message meant. At least all this troubleshooting is on theme. Yeah, this is on brand for my summer car, yeah. That is very true. You, sir, are correct. Okay. Well, at least I was into writing simple functions back then, way back in the day. Let's see what the effect of this is, and maybe we'll get buttons to work. I don't know if they'll work quickly, but we can get to the bottom of that. So turn that thing on, wait for it to come up, and then I gotta dangerously handle this fucking wheel. Damn. Okay, now nothing works. You know, sometimes the button works. The buttons would work in the other scheme, but in this one, nothing. All right, let's see what the scope says. Oh. Huh? Oh, because it was already running. Okay, turn it off. Reset the microcontroller. The microcontroller isn't resetting with the rest of the system, so it had no idea what was going on, and so we didn't get to the point where buttons would work. So we need to start it from the beginning, and I needed to hit the reset on the actual microcontroller. So now it'll come up and everything will start functioning. There it goes. All right, now we can zoom in. All right, stop wiggling. We can hit a button. Nothing. Damn it. Hit a button over here. Well, the earlier buttons on the serial scheme work. Oh, the triggers don't anymore. All right, more tuning, more tweaking and tuning we got to do. Well, that's what we're in for today, folks. See, all I can get working is the right button, the right arrow button. But it doesn't even work. Like, here's what happens if I hold it down. It's a button dance. All right, let's retool the. I guess we know it's reading consistently at the same time every time. I have it showing the 7 bits. If I trigger it a single time, oh no, I need to zoom out a little bit there. Trigger it a single time. Let me turn this off before things overheat, and we can see exactly what's happening here. It's probably a matter of just some tweaking and tuning. All these serial pulses are coming through very quickly, so if we can get it tuned up to read properly, we'll be in good shape. Now, I should probably hit some buttons so that we have some data that we know. Yeah, maybe I should hit a button. Because that doesn't quite seem to be getting to the end. It doesn't quite seem to be getting to the end. That's all the way out here. So this would be 7 and then a 0, and then a 1. If I move these cursors, 0 to 7, and then an 8. So it'd really be 9 bits would be 478 microseconds. Pull out the calculator. I mean the one on Windows. So, well, let me, plus the 0 and the 1, I guess. So this would be 10 bits. 10 bits is 568 microseconds. 568, well, 56 microseconds per. 56? 3, 6, 9, 12, 15, 18, 21, 24 microseconds. 568. 24 doesn't really go into 68. Where am I getting almost half a micro, or 50 microseconds from? Half a millisecond. This is a very fast speed. There's a lot of stuff going on. And that should be offset by half. That is not offset by half. That is way less than half. What is our offset over here? We're setting a half bit as 11. Let's set it like properly. Let's do like 25. So 25 and 50. The problem is when we time the external stuff, we are going to be timing it using that number, the same number. The other microcontrollers are going to be keying off that timing, and they should respond to it in kind. So I don't know why there's such a weird offset for everything. I mean, if we do our timing, if we tweak rise fall, that's a subtractive from 50. If I take that to like 1, is it going to suddenly make everything work? That would be bad. And if I adjust this, well, half bit affects the entire position of the signal, not the width of the individual bits. So if I wanted to affect the width of the individual bits, I could either mess with rise fall, or I could make another variable. That would be the additive adjustment. Well, let's think about that for a minute from now. What did I change? I changed the half bit. So let's upload that code, and I'll zoom out on the scope. Zoom way out on the scope so I get enough of the signal. We're trying to get a sense of where I'm looking for the 1s and 0s. This shouldn't need this much tweaking, but for some reason it does. And then we need to look at why the shifter code isn't working. We've still got a lot of bugs to shake out of this whole system. All right, so turn this on, hit run, reset the micro, make sure that this thing can come up into serial properly, and get all of its 1s and 0s all sorted out. When we register our module, that's what triggers this to happen. So single, and then we immediately need to turn it off because the wheel's wiggling, and it's gonna, yeah, it's a wiggle worm. That's a good, that's a good pair of emotes. All right, so we get that. Our 1s and 0s are fluttering about. I mean, that looks a little bit better. It looks like we are getting, so far, if our thingy-majigs are 50 microseconds. Let's get the cursors at 50 microseconds. Oh no, I disabled all the cursors. No! Okay, that cursor, bring that back. So what I'm doing... Shake it like your mama make. Okay, let's get that on there. Okay, we can see that scope a little bit more cleanly. I'm out of liquid. So dry. Okay, so 50 microseconds, right? We're looking right here. 30, 40, 50. So we are reading on the bitter edge of the next pulse. We should be compensating for the 3 microseconds that we make that pulse. And we're not even compensating for the read-write. We're not getting to the end of the 7 bits. Well, okay, so let's lock that one down. So let me move both of these at the same time and go all the way over here. That's the end of it. And then this is these are the end bits. So it's a 0 and a 1 as a stop bit. As far as I remember, and I could be wrong about that, but I think that seems to be what the case is here. Let me just look that up real quick, because I don't really remember. The LIN bus protocol is a very known thing. There might be an Arduino plugin that does LIN bus stuff for me. It didn't exist when we started the project, so... Or maybe it did and we just didn't find it in the keywords or whatever. I'm starting to get used to the look of me as like complete Sam Squanch mode, where like my hair is taking over the rest of my face. At some point, I do have to get my head shrunk. I have to get a haircut. I gotta do that. And I don't know if my barber, I think, closes on Sunday, so I might do that. Maybe Monday's a holiday. So I'm gonna be Sam Squanchy. I'm gonna be Obi-Wan for the rest of the weekend. But at some point, I mean, I'm just starting to get used to it. I've had so many bad hair days. I think it's when I turn like this, it's starting to look more normal to me, and I don't think that's a good idea. Yeah, Groove, I don't do that, man. I'm gonna have like, I'll have like a berries and cream bowl cut tam line. All right, LIN bus start stop bit. I just want to look that up. Our serial sniffer can analyze LIN bus. Not news. Yeah. Sync field identifier. Yeah, there's a start and a stop. So the 0 is the start and the 1 is the stop. Oh. What direction is this stuff coming in at? Hold on a minute. Hold on a minute. We could be reading in completely the wrong place. I know, it would be nice, but I need to go to like a salon. You see, I have beautiful hair. No, I need it to be done a particular way, otherwise it looks like shit like it does right now. It's like that. Every now and then go to a salon, folks. Every now and then go to a salon. You'll benefit greatly from it. What's going on here? Am I reading this properly? From what I'm looking at, the start and the stop, which one's the 1 and which one's the 0? Hold on a minute. Are they 0 stop bits? Delta checksum. So it's got the sync field, which is 0x55 is essentially what gets transmitted. It's 5, the binary number 5 is a 1010. Right, so it's just a pulse train that you can get timing off of. And that's what we do with the accessory devices. They actually get that initial timing, they key off of it, and then they use it from then on. So if we get another device to actually transmit a 5.5, that would be beneficial to us, because then we could see the 1s and the 0s and whether or not we are in the right position to get them. Each LIN ID is assigned to exactly one replying. This becomes clear considering the structure of the LIN message. This is like a crash course because I don't have long-term memory. I'm goldfish brain hacker boy. The header contains his message ID. Part of the message is always written in the bus system by the master. Blah, 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 blah. Do not reply to the receive ID. Sync break. Sync field. Identifier. And then the data field. It's 2, 4, or 8, depending on what the address of the master is. That's how they organize it. And at the end, you have a checksum. Well, I mean, we could look at the checksum, but I don't know if that's really going to help us. Here, hold on. If we go all the way to the end of the packet, Yeah, these, I mean, these look like 110, not 1010. We're looking for something like this. Here we go. Why does it zoom wherever the hell it wants? Okay. We might actually be on target with this. 0, 1, 2, 3, 4, 5, 6, 7. That looks to be on target. Well, let's see if the actual implementation of it sucks, because I think it probably does. We turn on the device. We let it come up. There's a lot happening in the background for those of you that don't know. There's a lot happening in the background. Is that like a weird like line at the top of my screen? Yeah, it is. I gotta fix that. Stop it. Stop wiggling. I'm gonna hit a button. Yeah. Yeah, it's not recognizing the buttons being hit. Hold it down. Really? Why do you forsake me? We had this thing working perfectly. I'm gonna hold down one of the triggers, and then we'll get a capture this before this thing overheats. Oh, we didn't reset the microcontroller. Hold on. Turn it off, reset the micro. Hold on a minute. This could be totally accurate. We have no idea. Hold on. Turn it on. Let it come up. Try not to have the wheel eat itself for some reason. I don't know what's going on there. I have a feeling it's something in the encoder is not hooked up properly. Okay, there's that. Everybody feels stable. Push a button. Oh, that's quick. This one? Ah, that one triggered too. Yeah, see, that one's still off by a little bit. So actually, let me just push that one, and we'll take a look at which one of the wheel modules being pressed. Because, yeah, that one button looked really stable, but the other one didn't. How about over here? It seems like we're getting closer. Yeah, it does feel like we're getting there. All right, so I'm going to hold this one down. Now, which one was it? This one? Which one? I want the one that was doing just chaos. None of those. This one, this one, this one. These are initial. Yeah, these are as solid as they get. Over here, that one's pretty solid. It's like sometimes when I release them, other ones get pressed. See, it should be able to just do whatever, but... All right, so I'm running out of time. I need to do this before the wheel overheats. We need to find one that's, like, crazy. Well, that one's close enough, so let's get our capture there. We actually have a really stable readout right now. Oh, wait, no, that's, yeah, that was single capture. All right, so I pushed one button down. That's going to be hard to identify, but let's turn this off. No, it's nothing like that. I guess coming up with weird ideas of what's wrong that aren't our serial data timing, you know? It's like it's very simple what's going on here. Very, very simple. There's our button. There's the button that we pushed. Beautiful. Look at them right there. So which one did I push? I pushed arrow left. Arrow left. Where does that one sit in the packet? It's all the way down here. So that would be the 4th bit of the byte. 3, 4, 5, 6, 7, 8. Yeah. So left. Fourth bit byte thingy of the thingy. 0, 1, 2, 3, 4. That's reading at a good time. So this pulls into question what I'm due. Because if we're getting an accurate readout of the buttons, and I guess I can put in the serial print of the wheel buttons to see if we're accurately receiving the ones and the zeros. Because that could mean that there's something else going on. My packing of the buttons into the serial signal could be what's problematic here. So let's go back over to our prints. We can leave all this stuff alone because it's actually doing its job. If we disable the pulse, I'll leave the pulse on so we don't have to adjust that. Leave the pulse on so we don't have to adjust that. But we go up to our diagnostics, and I'm going to print the wheel packet. Upload that to the micro. That'll reset the micro. We'll turn it back on. We'll see what we get on the serial port. We're not using much of this microcontroller at all. That's shocking to me because this is a lot of code. These are little tweaks and tunes. We just need to keep bouncing back and forth like this until we get it working. And I do wish that the wheel was coming up properly. I think there's a problem with something else. All right, my button prints aren't printing. So now we have another thing to investigate. Let me just do a single trigger mode here. Yeah, everything's communicating fine. It's just not... Yeah, I didn't need to reset. Everybody was communicating just fine. It's something with its serial prints. So print wheel. If def print wheel, and if. Print wheel. Print wheel. Address and hex. 0 to 8. Do that. Wheel of I. Hex. Serial print line. Why isn't that running? Oh, I'm not running serial prints. That's right. Okay, yeah, that's right. It was a multi-tiered thing. I put all these prints in here kind of haphazardly, so now that's in the loop. All right, so now it's in the ready state. Open up serial. Serial's ready to go. Turn on the module. It's going to just start puking data out once everybody's registered. This is doing all of the... There it is. All right. Ah! Well, son of a bitch, it's like perfectly stable. It's my thing that's fucked up. Look at how stable that is. Oh my god, it's so stable. Look at how stable that is. All right. My fault. They make it do different letters if I push down multiples. 4, 2, 1, A, B, C, D, E, F, and G. It's all the numbers of the rainbow. Yeah, everybody's there and they're having a party and I wasn't invited. So, all right, so I screwed it up. Cool. Well, okay. There's the address, there's the data, E0, FF, and then those are 0 zeros. And if I get them into the right state, I can do A0 or 2 or whatever. 2, 1, 8, 5, 4. Okay, all right. So we know, now we know. Now we know. No. These are just ones and zeros in a register, my guy. They're just ones and zeros in a register. They can't hurt you. I need more drink. It's just where I'm getting them is the wrong spot, basically. All right, have a stretch. I need to check to see whether or not the wheel matches the wheel and then put that into the code, or I can just throw them into the register every single time, and I currently have it checking to see if there's a change in the register, and then that'll change it to something. So I can do it either way. Every loop of the program, I could just have it check to see if there's a difference, and if there is, program, you know, send out an external signal. That's not how it works. They're just ones and zeros. Yeah, we're just printing out what the bytes are. You guys are smart enough to know that. All right, so this should work. And by the way, we're looking at the registers that we load stuff into. So we know it works because we're reading back and serial printing the registers, and everything is fine. So we can get rid of these, and then I can go to Lynn's stuff. Whatever's happening all the way down here is what's cursed. Because yeah, these should all be good. Okay, so we'll get to the shifter in a minute. I just the wheel's the thing that always works no matter what, so we need to lock it down. We need to lock it down and make sure it works. And then I need to make sure that the encoder is properly communicating with the rest of the system, because apparently something's screwed up, and so everything's haywire right now, which is not to say that there's actual hay inside of this thing, but something is causing it to go weird. See, when we print the wheel, we're just printing out the address and hex for 0 to 8, and actually what I should do is turn this into printf percent 2x wheel of I, and that'll just clean it up. Do it down here too. That'll just print the whole thing instead of it truncating the zeros. See if we're doing that anywhere else. Printf percent 02x. Don't put 20 in there, you'll mess up your code. Shift 8. Get rid of this. I forgot the other quote. I'll get there. I'll get there. We'll just clean up little bits of the code until we get everything working. Welcome to my stream. Let me go to the programming layout, because it's a little bit more sensical. Ah! It's all over the place. I can't make heads or tails of. Okay. So I don't know why things were wandering around in the way that they did. There's something wrong with the logic here. There's something wrong with the logic of my code. Something is awry, and I would like to get to the bottom of this. But we're reading exactly where we should be reading. I mean, this microcontroller, this TT 3.2, like no surprises at all. Like everything works. It's on lockdown. We're reading exactly where we want to be reading in the signals. So we don't actually need. I don't need to do that. I could just do printf. The print bits function is obsolete, because somebody taught me that you can do print. Damn it. Printf, and then you can do I can use a computer, I swear. I swear I can use a computer. God, it's nice to be here alone. There's no other weird like noises in the house that I need to worry about. Also, that dentist drill has stopped, so that's nice. Yeah, anywhere that I've got print bits, I want to replace with a printf. Decimal, Oh, this is for the other printer. Oh, whatever, it doesn't matter. I don't know if I need to do, I don't know how to use this in decimal though. we'll just print that in hex. I'm wondering if I could do percent, do like percent and then like 16D. I don't know if that's how it works though. So we'll just keep it in hex. Why not? Here I'm turning the shifter into a word. Let's do, oh wait, I'm not. Shift date of 1 and 2. I'll just do this. Put a space in there. And then I'll do 2. And we won't do it in a word. Cool, yeah, that's exactly what I... Keep it simple, make it look like my other code. The pedals, I may leave alone, although print bits, they're supposed to print, what is, so, %I, will that, if I do that for like this, because I want to print the bits there, but I want the zeros in there, %D? So if this was... like that. The number specifies the fixed amount of digits. Ah. So for the pedal address, 0 to 6. I don't even know what this code is gonna do. Yeah, that's what I thought it was, but I thought it was like regex, so it might be cursed. But then the times that I've put 0x, or sorry, 20x, I've had it print 20 digits. So I suspected that it might be a little bit better. What am I trying to do with this one? For an I is equal to 0, 6, I don't think I need to do that. I was putting walls in between, oh, pedal of I, so from pedal of 0 to 6, I wanted it to be in 1s and 0s, but have all the leading zeros. So if I'm printing each of these is a byte. That's a byte 8. Like that. Because that cleans it up significantly, and I don't need this function anymore. That stupid function that I thought I needed. Gas, clutch, and brake in decimal. Oh, was I printing that in decimal? Might have been. No, I was printing that in binary, so I want to keep that in binary. I don't know. I'll have to come back and edit these if they're totally and completely cursed. So I'm just looking at how I'm presenting the data right now. What I want to do is I actually would like to look at the 1s and 0s, to be honest. Well, if I need it to be in 1s and 0s. Let's do like now print wheel bin. I don't know. I was thinking about whether or not I wanted to make a function that would print it in binary instead. I'll just do a line under these that print and then since it's wheel of I. Wait, did I? Huh? What happened here? Why is there wheel of I instead of wheel of a number and it's outside of the loop? Okay, so we're printing all this stuff. 0 to 8. How many is in the wheel? The wheel was... Where's my serial print? Hold on. Before I write over the program, I could do a cheaty serial dialogue. Just so I remember what's in there. How many fields? Good enough. Turn it off. Turn it off before we lose everything. Oops. That's a little much. Notepad. All right, so what do we have? So 0 is the address. That gets printed first. And then we go for I is equal to 0. What? 0 to 8 wheel of I. Oh, okay. All right. So that's just 0, 1, 2, 3, 4, 5, 6, 7, and 8. So I don't need the second one in there. I don't need this. And then over here, well, let's just check. Is it 9 or 8? 0, 1, 2, 3. Oh, no, sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's actually 9. No, 0 to 8. Yeah, it is 9 positions. But instead of bar, let's do, so it's not confusing as to which one is 0. I can just do that and then serial print, and then it'll be colon. Print a colon out, and then don't get my channel banned. All right, so like that, and that'll just follow it up with a butt. I mean a wall. And then wheel of I, and we're printing it in hex, or printf, and then, oops. Well, I could just do the first 3, and then I think I had that coded before. If def wheel hex, and if and then define wheel hex if not bin. This would be on elif for int I is equal to 0. I is less than or equal to 3. I plus plus. And then we do serial print function percent 8d and wheel of I. Ah! Wheel of I. And that, do that. Serial print print wall. Done with that. For int I is equal to 4. I is less than 8. Oh, you know what? Less than or equal to 8, because we want that 8th to print. That's the checksum. Less than or equal to 8, and the rest of this follows the same way. Man, when you got the framework of the program all together and you're doing stuff like this, you might, for a second, actually feel like you're capable of coding things. And this is end if. There you go. So what happens is, if I say wheel hex, we print the whole thing in hex. Otherwise, I print the beginning in hex, or sorry, the beginning in, we print 1 to 3, and then we print the, oh no, but we've already printed the wheel address. Never mind. We 0 to 3 in binary, or wait, is D is not binary. I think I need B in there. Printf binary. Boink, and then DX or O. You cannot do this, as far as I know, using printf. What? Son of a bitch. So what I was doing before was correct. We might need a couple of Control-Zs on this thing to get back to where we were. Son of a bitch. You? What the hell is that? Is that, String cat? Oh, God. Programmers suck. All right. Oh, good. It's not on the page. Sons of bitches. Nobody's talking about printf. I thought printf would have cleaned it up. It's not a thing. Well, where were you a minute ago? Oh boy. Okay. All right. So let's we'll preserve this code, but copy, and then we're gonna Control Z as far back as we can until my function reappears. There it is. Okay, so at least we can print bits this way. So anywhere that we're trying to print binary, we need to reinstate that thing. So yeah, all right. So let's take this and let's put this back in. And then instead of this, we need to print bits. And then we need to give it wheel of I. I thought we could get around that with printf, but it turns out, nope. 0, 1, 2, 3, wheel of I, we put a wall after it. Wheel of I, that's going to print it out as a bit read directly so that it'll do it and make it look good. So anywhere we want to print binary, that's what we're going to do. That would be here. You really want to print that in binary, though, for the pedal? That seems like an odd thing. No, that one wanted to be in decimal. So actually, that would be 3D. 0 to 255 in decimal. Right? Not really sure how that function's going to work when we try to make it work. That one's going to be a little bit crazier. Pedal of 7 in hex. Yeah, I don't know. We'll have to check that one. That's going to be a little weird. Okay, so maybe that rescued it. I don't know. Where's my print shift date? Shouldn't that one be in binary? I did that one in this. Shifter should also get a shift hex. So from here, we want to do, from this, we want to do, I need to move my drink so I don't spill it because it's red. Red drinks are dangerous. If def, shift 8 hex, and then we want the print line at the end of the program anyway, and then delete that. I'm just making some nice looking printouts. I don't know how I feel like using my time right now. This one is going to be an elif. And then otherwise, we're going to print it in binary. What's up, Arash? How you doing? So we want to do, we want to use my function. Print bits. I'm going to use this one. Finally caught a stream. Yeah. Trying to get more regular about Saturdays. I don't know. Sometimes I'm just not up to it. Yesterday, I had too many real world things to do, which was rough. I mean, it was like, I was in like a storage space. Like 90 degrees. Print bits 1, and then print bits 2. Shift 8 of 1, shift 8 of 2, and I'll put a wall in between them. Okay, bits, wall, bits. What's this one? This has all kinds of crap going on. So we got wall, and then we have bits, and we have wall, and then we have bits. I didn't quote my wall. Elif, and then endif. There. So if we do shift 8 hex, then we get it in hex. Otherwise, we get it in binary, which is a special way to do that. Real world is gross, yeah. We are grinding coffee by hand. Are you like that like technology guy that builds a mud hut? What are you doing? Do you have electricity? By virtue of the fact that we're communicating, you have electricity. Hey, I guess you know what? You know what? It's like the only alternative form of exercise that your right arm gets. So you might as well also grind coffee with the damn thing. My PC consumes all of my power. Oh damn, dude. That's a righteous thing. Hey, I'm happy you're watching my stream with what limited amount of power that you actually have in this world. Cheap electric grinders suck, but cheap hand grinders are a better grind. I can understand that, I guess. I don't know. I could probably taste them side by side and I wouldn't notice personally. But I'm an engineer. You know, coffee is like a transaction to us. All right, so there's a slightly more capable print for that. Pedals, I'm gonna have to work on a little bit more in order to make more functional prints out of it. I mean, I need to recompile every time that I do this stuff, so I just wanted to kind of poke into here and kind of clean up some of these prints so that we'd have a good idea of what's going on. But we've already learned what we needed to learn from this, and that's that our prints are clean. We're not leaving fingerprints anywhere. As long as we're putting the right data from the right spot into this program, I mean, but that's where things get hinky. That's where we have kind of trouble here. Trouble being, I don't know. What's that one? Oh yeah, the print analog readouts for everybody. Interesting. Smashing versus using a burr, yeah. Just use the replicator. You gotta bark at it. You gotta bark at it. Tea, Earl Grey, hot. And then it goes meow, and you get your poop that's been reconstituted atom by atom into tea. You get your poop tea. Okay, so potentiometers out. We don't worry about that. That's all. Supposedly, that's all dealt with. Our signal was very stable, which is disconcerting. I was a little concerned about that. So what I'm doing here is a mess. Really, to be honest, it should be working out okay. It is a mess because I'm going through piece by piece and I'm extracting the data that I want and I'm putting them into a 16-bit button register. So, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. I'm charting them into something like this, into the various locations. So from 0 to 7, 0, 1, 2, 3. Is it this side? No, the least significant bit. 0, 1, 2, 3, 4, 5, 6, 7. So I'm taking the first 8 bits of the wheel, which are these, and I'm putting it in here. 1, 2, 3, 4, 5, 6, 7, 8. Wait a minute. Oh yeah, because it's 24. Wait a minute. Oh, it's UINT32T. And it's actually it's 4, 8. So that would be 16. Like that. So in binary, it's like enormous, right? So actually, I think I'm starting at the wrong part, and I'm moving the wrong way. But that's the most significant bit. So 0 would be the least significant bit. So it'd be over here working this way. And then it's little endianed into place. It's all fucked up and moved around and stuff like that. I wonder if I should be printing in binary what wheel 1 looks like. or what buttons one looks like. But if I do that loop to loop, it's going to be this big mess. Give me some shit packed with caffeine and I'm good. Yeah, that's kind of how, that's like what this stuff's supposedly an energy drink. I don't feel any energy drink properties from it, but okay. Hello Code. Hi, it's me. It's me, the confused streamer. I don't know, something cursed is happening within all of these loops. I almost feel like I should just be assigning them one for one in here. What if we did that? What if we actually assigned it position by position for absolutely everything? Absolutely all of these are position by position, just as binary assignments. It's a totally cursed way to do it, I know, but you know, and that's kind of what I'm thinking too, is you know, just make it work. Just make it work. So what would that look like? That would be button. Well, it would actually be we're gonna have a lot of bit sets in here, right? Wheel of 0 position something. So we'd have bit set, because I'm too lazy to program this any other way. Buttons 1 with bit read wheel, lowercase wheel of 0 0. We're gonna have a lot of that. Oh man, this is gonna be cursed. Wheel of 0. I'm gonna do it though. I'm gonna do it. You fuckers can't stop me. Wheel of 2. That's that data. Shift of, and I think it's shift of 0 is where data is. I'm not really sure because I haven't seen data coming back on the shifter. If we look at the scope for that, if you look at the scope for that, we don't really have anything happening in here. I think the shifter might not be connecting properly. I think that's the shifter. I think the shifter comes afterwards, but it's like something's happening here. We're not replying at all. So I don't like this method because it's not very, I don't know. It's just weird. It's a lot of, we're like wasting cycles. You know, there's only, it's like the human body has only a certain amount of energy in it that you're eventually just going to expel. So eat at McDonald's. But in that same vein, we've only got so many cycles in this microcontroller, right? 1, 2, 3, 4, 5, 6, 7, 8. God. Oh, it's disgusting. Now, we're not going to have as many on the other ones. We're only going to have 4 on the next one. And then 1, 2, 3 on the one after that. Hey, at least it's direct. And then the shift 0 gets all of them. Instead of wheel, it's going to say shift 8. So that's the of thing. Shift 8 is 0. How sloppy is this, though? I don't know why the shifter is not working right now. That's kind of concerning me. Oh yeah, that's actually not the assignments. The assignments here, 0, 1, 2, 3, not 20. I can just go up the line. Eight, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and Twentington. Now, my question is, are we overwriting the F0 in this? Because we're going up to 20. So that'd be 0 to 3. Those two would be 0 to 7. So we shouldn't be overwriting that, because that's 32. Ugh, I hate it. Oh, I need to wait a minute. I'm not done. No, I need to do. Oh God! All right, hold on. These functions are all messed up. Hold on. It's there's a couple functions, and one of them has 3 fields. So bit read is variable position. Bit set is different. Bit set. Oh, that sets it as a 1 or a 0. It's bit right that I want. Yeah. Number, and then so the numeric value which to write. Sorry, that's the variable to write, which bit of the variable to write, and then the value. So I screwed it up already. Let's get rid of all these. I can redo this. I can redo that. I can fix this. 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 Nothing happened. Nobody saw anything. Bit right. I can fix this. I can fix this. I can fix this. Bit right. These are just helper functions that just make it a little easier to work with. What's up, Copper? How you doing? Bit right variable. It's variable. Which bit of the number starting with 0 for LSB? So this would be. I'd want to write 0 with the bit read value of wheel of 0, and then double parentheses to end up the function. Okay, so we want 1, 2, 3, 4, 5, 6, 7, 8. And then I want to take the read of 0, 1, 2, 3, 4, 5, 6, 7, wheel of 0, and then buttons of 0, 1, 2, 3, 4, 5, 6, 7. This is the least clean way to program this. But anyway, the next one we have 1, 2, 3, 4, right? So take 4 of them and go in here. And so buttons 1 of 8, 9, 10, and 11 are coming from wheel of 1, because we're in the second byte. These are all previous notes that I've taken. But remember, we don't set where these things come from. This is whatever Mercedes decided to do for their vehicle. So Mercedes said, hey, it would be really cool if we had this data here. Oh, but this steering wheel doesn't have this button. So when we register this steering wheel, we don't use this one, but sometimes we use this one. It's all a big mess. But that's how the LIN bus is set up. So 0, we want 1th, 2th, 3rd, and 4th. So 1, 2, 3, 4. This is a very direct way to do it. It is a little sloppy, but I don't know. At a certain point, I got too many years under my belt to be worrying about how sloppy my code is. So we want 1, 2, 3 out of this entire thing. So we're going to be reading wheel of 2. not 21. Wheel of 2, position 0, 2, and 3. So that's 0, 2, and 3. If I'm correct and these aren't flipped around, we'll probably have to investigate that. Maybe I can do the binary prints if we have trouble with it after this. Because whatever I did down here was just cursed. I'm going to delete it. I'm going to delete all this. All this work is dead. Goodbye forever. And for some reason, the shifter isn't responding, and I'll have to get to the bottom of that one, too. So, all right. So we got that. Next. The shifter, we want the whole thing. The only thing you might want to do to improve this is doing the same with what I would assume would be byte right. Huh? This is position 11, 12, 13, 14, 15, 16, 165, 16. Oh, wait, no, I didn't do that yet. 12, 13, 14, 15, 16. No! I'm not looking at the numbers as I'm doing it. 17. No, 188. Hardcore microcontroller people would be like, why don't you just use the bit shifts? Well, because they're confusing. And I don't want to... These do everything elegantly in one line, so... Yeah, there's probably a function that does it for the whole thing. I could probably do that. I mean, if I really... Look, if I really wanted to do this the way microcontroller people would, is I would take this stuff and I would shift it selectively. I would put up masks and I would shift it and then I would punch it into the thing and stack it all together and then push it all at once. And that would probably be the fastest way for me to do it. Instead, I have it shifting individual bits over. Now, because this is a teensy, it'll be doing it in a millisecond, and we should get some pretty good response on the buttons this way. If we can get it to be as stable as that serial printout was. Yeah, so we don't have to worry about that. We don't... What? I have these backwards. I have these reversed. Hold on. Try to keep my nomenclature standard. And then anything else we have in here? No. Yeah, these are just the buttons. Okay, okay, so we are writing positions, and that's going to be 0 through 7 from shift 8 of 0. I got to change the ones above. No, that's still wheel stuff. So yeah, shift 8, shift 8, shift 8, shift 8. And then the analog stuff is handled separately. That has tuning and stuff that we've done. We did that already. That's for the weird port expander. And then here we have the digital pot outputs, and this is where we're doing all that stuff. So, I mean, this isn't optimally, I don't know, this is the same thing as just shifting it a certain number of positions, right? Only I'm getting rid of the ambiguity and saying, hey, why don't you read that value and put that into that one? You know, we could instead just like XOR mask and shift into positions, but I'm not as comfortable doing that. And I feel like it all comes out in the wash. I feel like it's all about the same number of cycles. Why is that one a different length? Oh, because it's missing a comma. I feel like it all comes out in the wash because we're not exactly... We might save like 16 cycles of the processor, which is nothing. Not 16 cycles, 16 like pulse, like you know, whatever. Attained a fancy light bulb that allows color temperature settings. Those are nice. Really wish the new light sockets were a bit different so that you could send a data signal from the switch to the bulb instead of having the bulb have to be a smart bulb. That's just never going to change. Yeah. I don't think we're ever going to get a bus line. That would be cool, though, if houses had like a standardized bus line, but then home electricians would be tearing their fucking hair out. It's way too much for them to have to worry about, man. They know what they do, and they know how to do what they do, and if you throw them a curveball, they will get it wrong. So mixing like a signal with the high voltage is just not really in the realm of stuff that we should be doing in homes. Boy, if I wanted to implement buttons too, that would be a mess. All right, anyway. Buttons. When the button register changes, our program detects that and sends out a signal. So if these get held down, they remain in the position that they were in before. So then this should all work properly. Let's see, yeah, let's see, you have like an Ethernet socket on all your bulb sockets and stuff. I think having the wireless protocol is probably better. What I did with my network is I set out to have like a block of IP addresses that are all just smart stuff. So if I get overwhelmed and I want to start looking at like, why is this light bulb on? I'll drill down to the IP addresses and be able to get into the individual device. I think that's a good way to do it because on like a wireless network, there's a lot of information that you can glean from something and you can have it have its own individual web page. I just need to make sure that I can Tasmotize everything because I don't know who's in my bedroom. I don't know who's in my bedroom anymore. I know Jeff Bezos is there occasionally. Is Elon Musk sitting in my, is he sitting on my pillow right now? He might be. I need to make sure that I know who's in there. I mean, the FBI guy has his own little thing that he does. He actually has to walk in a circle 3 times before he lays down. It's very cute. But other than that, like who's there? Who's in my bedroom? I don't know. The Supreme Court, obviously, they're there. They just made their own little. It's getting. I don't have a lot of space, you know. I don't have a lot of space for that many people. But you know, I'm tripping over robes and shit when I get in there. So yeah, if I can Tasmotize my stuff, then I don't have Xi Jinping hanging out as well, because he doesn't get along with anybody. All right, so let's upload that to our microcontroller. Maybe, just maybe, everything will break. How do you do else-if? Hold on. C else. Oh, is it a full else-if? No, it's elif. Oh, else. There's no if part of that. Else. But that means that this will always be implemented. I guess it's either or, yeah. Because it won't print this. Yeah, we just do else. Okay, so we just do else. Is that the only place? I had it somewhere else too. Yeah, else. Yeah, because if you enable the digital print and then you tell it whether it's hex or not. Instead of screwing it in, you lift a lever to untighten the socket. You want a ZIF socket on your light bulbs. Yeah, that's a ZIF socket. I don't know. It could work. You'd have to engineer a new power socket, and Lord knows we have a lot of those. I think we have a good number of we got a good number of bulb sockets in existence already. I wonder if something exists like what you're looking for. Hold on. Bulb socket with data pins. Yeah. Nope. There are some of the newer stuff like coming out of 3M and the like are like for motor controls with like, you know, like radio control stuff and things like that. They'll have like the 3 motor sockets, and then they'll have a couple data pins on that as well. There's a lot of cool stuff coming out with that. I don't know. A light bulb should be a light bulb, man. And a light bulb man should be a little guy that runs around. All right, anyway, let's close that. All right, that uploaded, question mark. Let's see if we've stabilized the process of hitting buttons. Oh, I need a, hold on, we need this one. Oh my God. Back to regular production mode, where my face is half covered by chat. I should probably insmollinate the windows on this one. I actually need to do this. Hold on. Color source 2. Let's just give that a little. There we go. I should probably insmollinate this one so that chat has their own little block. Anyway, yeah, it's that XKCD where there's another standard. Let's see if the buttons come up. Let's just do a Hail Mary. Mother of God, got the whole host of angels shuffling in my iPod. Nobody understands that reference, bother. Nobody understands the music you listen to. It's all shit from the early 2000s. Everybody thinks it sucks. Okay, stabilize it. Push a button. Weird, there's like a little hunk noise when I push a button. I think it's fighting back. Oh, good, that one permanently pressed. It's still fucked up. So the question is, are we overwriting the button address badly? It's certainly, I know it's not slow because I've seen it react to buttons very quickly. It's just right now it's doing weird stuff. What do the serial prints look like? Oh, we don't have any enabled. Okay, that's our next step. Now the other part is that we want to add, we need cinnamon. We want to add, I want to add a button printout. So when the button register changes, I want to print out the button register. So print but. So let's put a print button in here. Print but bin. It'll be in binary. It's going to be a giant signal. It'll be a lot of ones and zeros. But we've got a lot of buttons, so we might as well put it forward and just print all of them, right? That's over here. Define print but bin. And we'll define it, even though we haven't written it yet. And if we're doing that, we're going to go over to linbus functions and do, well, do we do that in linbus or should we just print it whenever it changes? And if we print it whenever it changes, we already know what it's going to look like. It'll only change when things go haywire like they did over there. Why was everything so haywire though? Because if we look at the wheel button addresses, everything is super stable. It's super duper stable. Well, let's we need at least just one printout of the whole thing. So I guess print but bin print button 1 end if. There's a weird little function right here, this serial prints, because I need to enable this in order to get it to work. All right. Weird if-def statements that'll make my program look like complete ass when I get rid of them, huh? Print button 1 void print button, it should be buttons 1. Because the variable's called buttons 1, right? Right? Yeah, buttons 1. Scroll back down, all the way back down, down. All right, print buttons 1. 4 int I is equal to 0. I is less than or equal to 24. 24. Your Philadelphia Sixers. I++. And then 23. I++. And then I want to know. Wait a minute. What do I want to do? I guess I just need to rewrite this. Serial. Oh God. Serial dot print bit read buttons 1 I. Right? That's what I want to do. So for 0 to 23, I am just going to print the bit read. I'm just going to rattle the whole thing out. That would be for print buttons 1. So at the end of that, we'll start off by just being polite and just say serial print buttons 1 with a space. And then it's going to be a big nightmarish thing of 1s and 0s. And then I'll do serial print line. And that's just going to hammer away. Technically, I wanted it to print every time there was a change in the buttons, but for the sake of looking at how stable it is and maybe figuring out why it's not, it could be that we're pushing a checksum into there or something like that. So I just want to make sure things are stable. I don't know why there's the disconnect between this variable and what I'm seeing in my registers. So that's what we're going to try to get to the bottom of right now. So there's buttons 1. There's our function. That's going to cause chaos. Upload. Every time I upload, the microcontroller resets. That's why I'm getting away with it. Oh no, what did I do? Oh my God. Upload. All right. All right. That serial started. Get ready for some 1s and 0s to get pooped out of this thing. We're not as far along as I thought we would be. I thought we might be like a couple little tweaks from getting this thing running. All right, all 0s. That actually should be F. So which one is our nth position? Those are pretty stable. Which one is closest to 0? Scroll, scroll, scroll. Wheel of 0, that's the up button. What's up with you? Okay, so I think we need to push that to... I think we need to push that up 8. I don't understand. This is super stable. What the hell, man? All right, turn that off before it overheats. We have some hardware to look at after this, but we need to push this up 8. We need to push this up 8. I just got to do this. 13, 14, 15, 16, 17, 18. Wait. Yeah, that's the right thing. 19, 20, 21. Yeah, it is. It's scary stable. So why isn't my program reading it properly? I think maybe because it's overwriting whatever that last register is, and that makes it not accept the packet. Wow, that uses up the whole thing. We use every part of the cow. Every part of the cow. All right, let's see what we get here. That might stabilize us. So we're getting through all of the serial configuration bits and stuff, everything. It's a whole lot of components are falling into place in order for us to do what we're doing right now. Modules ready. There's no F0 as part of this. Why is that not F0? There should be 1111 at the leader of this. I don't know why that's 00. What does this thing say about that? Well, those appear to be... It doesn't let me hold down certain ones. Like when I release that one, you see how it's pressing the one next to it? That's weird. But then my ones and my zeros coming in. Perfectly stable. Perfectly stable genius. The lack of F0 on the packet might be screwing it up. Yeah, because it's like acting really weird. What the fuck? Okay, all right. So turn this off before it overheats. What are you doing? What are you doing to my beautiful code? Where does our button packet start out? We're over here. Blah, blah, blah. Buttons 1, F0, 32T, F0, 000000. Now, if we're printing this, I might be printing it the wrong way around. Because we're printing it, the first thing out of this is, oh yeah, we're printing it backwards. I should be starting at, well, I'm only going to 24 too, that's the problem. I is equal to 30, uint 32t, I is greater than or equal to 0, it'll be 31, because we start at the 31st and we I minus minus until it's equal to 0. Is that the correct way? I mean, it's the way I'm doing the other binary things. So that'll start us in the right spot, I think. And then I need to make sure that we are putting the right stuff into the right places. Oops, where am I? Where am I? Lin stuff, there we go. Getting this stuff to print straight will mean that I'm able to work on this. You guys argue about stuff I don't care about. Okay, I'm loading it up here. So we're starting at position 9 because we are going from nine to 31. 9 to 31. Of course, the last one is on the shifter, but I can't even get to the shifter right now. It doesn't really work. I don't know why. I think maybe just a signal thing. Maybe I'm not plugged in right. Okay, so buttons, buttons, buttons. Starting at 9, 10, 11, 12, 16, 17, 18. Now we see it writing the register, but then that F0 is not in our packet. And what's going to happen is when we transmit it, because of little endian, that ends up at the end of the packet. That's all I really care about, is that the beginning of this thing says F0. We haven't even seen it. Maybe it's because we're not printing the whole thing. Let me upload this. Let's run it. Let's see what it looks like and see if we get the whole thing in there and see if we're not overwriting. My theory is that we're overwriting that F0 and the packet just hates me because of it. Oh man, it's been every evening, every time the sun go down, we get fireworks noises coming out of here. Personally, I don't think Merca has earned all of her birthday fanfare this year. I think we're overwriting that F0. Because I mean those first 4 should definitely be 1s. I don't know in which direction. I don't know which direction we're talking about here. All these packet directions are all messed up, huh? Yeah, I'm used to readouts like this for these kinds of things. I mean, it could also have it print the packet that it's sending for the just for the wheel. And then we can see what that F0 is supposed to be. That definitely starts out like this, so I don't know why we're not. What if we go back to having them on the other end? Try that. Means I gotta renumber everything. Oops. Here we are again. Number 8, number 9, number 10, number 11, 13, 14, 15, 16, 17, 8 of teen, 19, 20, 21, oops, 22. Okay, try that on for size. I just don't, and if the F's are, oops, wait, what did I do? If the F's are missing, we got to find out what's overwriting them. They should be there. They should be there. That's what the packet expects to see. Wait for it. Wait for it. It's doing a lot of negotiating right now. There's our F. So what does that mean for this? Oops, stop wiggling. Well, it's still wandering. I don't know why the buttons are wandering. When I press and then release, it's briefly hitting a button. It goes boop, boop. See that? Boop, boop, boop. And then press, press, press. It should be stable. Like that. This is what my code is seeing. So why is it letting go? That one is stable. That one is stable. That one's good. Press and release. Press and release. Some of the buttons aren't doing their jobs. But if we look at it on this printout, they're fine. They're perfectly stable. That is as clean as it gets. And this is, by the way, is loop to loop. And that should just be, 3 buttons pressed down and then released. And it really should only be 3 packets going through there. Interesting. So something weird is happening on our loops. Well, now we know that our button registers are going in properly, right? Because we see the F0s and we see everybody else doing their thing. The shifter, of course, doesn't have anything to say in this transaction. It still needs to be worked on, even though I thought it was working. So let's close that. Let's turn this off before this motor fucking... Oh yeah, the motor's like nice and warm. I'll have to take a look at the physical setup within that. So for all the port expanders, it would be packet A, packet B, and then that whole thing gets thrown in. I don't think I want to... Let's get rid of all this. I'll need to set those to a 0 or something. That's a little cleaner. Yeah, I need to look at that now. I don't know why it would be disengaging. That actually needs to be over here. I don't know why it would be disengaging it, though. Yeah, good enough. All right, okay, so what is happening here? So we're doing everything we should on this side. The LIN bus stuff seems to be pretty stable, apart from the hardware weirdness and the wheel freaking out. But LIN bus stuff seems pretty stable. We're reading it at the right intervals. We can keep the pulses on this thing for now. We don't need to min-max it or anything. The shifter I will take a look at later. We haven't looked at analog yet. When we left it off, it was all working, though, so. Oh, absolutely not. We're using microsecond timing, and we've been using the pulses, the 3 microsecond pulses, to do everything we need to do. There's no running out of timing here. We're perfectly fine on that front. The only thing that I would be concerned with is if it thinks that we've disconnected from the serial bus, but it doesn't appear to be the case. Even with the LIN bus added in there, everything is pretty stable. I want to take a look at, let's see when this thing registers a change. So we are looking at, let's see, this is our send engine. In the functions, for the serial stuff, I have it looking at the button register. So we have our butt check. So status 1 is F3F. That's a block of dead code. Butt scan. If buttons 1 old is equal to buttons 1, and buttons 2 old is equal to buttons 2, we don't do anything. If the old register is equal to the new register, well, we don't really care. If buttons 1 of old does not equal buttons 1, then we do something. Send a button packet with the handle of 1. Send button packet should do what it, should do its thing. So let me do like a serial print line my butt. And let's just see where it registers its butt. Talk to me about your butt. Let's upload that butt scan. What's up, Warsaber? How you doing? I'm trying to get this fucker done so that I can beat Rabaz in the rally before he gets to it. He's been trying to do the My Summer Card date, but that's not worked out too well for him. Oh yeah, we're looking at a serial print. We got a weird inconsistency with the way butts are displayed. Because for some reason we see buttons that get pushed and unpushed during the process of this. So we're gonna have this going by. Okay, all right, calm down. My butt, my butt, my butt, my butt, my butt, my butt. Okay, it's not us. It's not us. It's not our butt. Our butt's fine. Okay, that button doesn't register at all. That's a problem. Press, release, press, release, press, release. Push to talk button isn't working. Why is it releasing like that? Is it that the wheel is connecting and disconnecting? I don't see any evidence of that happening. I hear thunder in the background. Ah. Total stable genius. Stable and wonderful. Psycho. 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 Stable? Psycho. What the fuck? The like middle of the packet buttons are the ones that are screwing up. I know, Robin's actually finished the rally. Well, if I beat him at it, it might incentivize him. So let me press a button and turn off auto scroll. My butt. My butt. Well, that seems perfectly fine. Here's a change. My butt. Here's another change. My butt. Let's see. So there's two things that we could do here. I think I need to put the button presses onto the scheduler, onto the packet scheduler, but I need to speed them up if that's the case. Because what might be but that's not the... No, but it's consistently affecting the middle buttons in that if I hit a middle button, it'll push and release. Is it like a configuration thing? Pin 7 is a shift button. These are configured as buttons. No, not encoders. Button order. Some older games show the first 32 buttons. Simulate. Yeah, we want our wireless wheel before X12. There we go. That's nice. So now our buttons are the first. Still doesn't mean they're... Well, let's save and push those over to simucube. I need to investigate why the analog's all messed up because it's not working with me right now. I'm suspicious of whether or not we're not doing something. Why would it be? But like, okay, so if our packet is hitting stuff, if our packet's running into stuff that it doesn't like in the middle here, that doesn't make any sense, does it? Oh, yeah, thunder's rolling in. If we lose power, the stream is down for the rest of the evening because we're getting in on the amount of time. But I want to keep going until we get this right. I'm looking around at the settings to see if there's anything. I don't really see nothing. I don't see nothing. Notifications, blah, blah, blah. We did that. I didn't do the motor encoder and center. Advanced. Any USB configuration, force feedback state. There's not really anywhere for me to go with this. I'm just wondering if it's like some other kind of thing that's going on. I think we need to look at like when we're sending packets now. Everything else seems perfectly stable. I'm going to turn this thing off just so it doesn't overheat. Let's investigate hardware and think about what's going on there. Because I don't know. You know, the my butt print was coming through only when there was a change. But then in the unit itself, we see the button getting hit and released. The only thing that I can think is happening is that the module is somehow disconnecting. But there's no evidence of that because the paddles, the side buttons, are 100% stable. They're working just fine. The only thing I can think of is maybe the way that the button is reported, it thinks it's an encoder, but I don't. It shouldn't be permanently wired up as an encoder. So if we're sending it a packet that represents the position of the button, I wonder if we're sending it on a part of the packet that it doesn't like. But the packet was fairly clear about what is what. You don't know what is what. You just strut. What the fuck? I mean, I guess I could hook up we could turn on the packet scanner and have it just print out button packets, and then we can look at the middle buttons that we're having trouble with and see how those trigger in the system. And see what they look like, because there might be something special about them. It might come in on the packet in a location that's different. And maybe before that, I need to mark down which buttons are which. But first, I want to solve the problem where this thing is trying to take my hand off. I really don't want to get rolled up into my own into my own steering wheel while I'm trying to use it. Man, this should have been super easy, right? Shoulda, coulda, woulda. Oh no, I'm out of my squirty energy drink thing. Oh well. Oh well. That's how the crumble cookies. All right, so we're not getting good data back from the encoder, and I don't know why. I don't think we did anything that would have wiped settings inside of this thing aside from hooking up the oscilloscope. But I mean, really, all we did was take the circuit board off of it. So I'm gonna power everybody down, and we'll take a closer look at some of the plugs here, because I think maybe moving them around severed something. Let me put all my video windows back to where they should be. Bada bing, bada bang, bada boom. Take a look here. See if we got any broken connections on this thing. I'm not just gonna like ohm it out. That'd be boring. I guess I could. I could just get the OSCA or the get the multimeter over here and just ohm it. Let's disconnect you guys for now. Oh boy, big thunderstorm is approaching. Watch it be a doxing storm. This happens occasionally. I get a thunderstorm and it's like literally over my house, and that's it. Let me just check real quick. Yeah, it's gonna fucking dox me, isn't it? No, okay, there's a little bit of a path going on here. It's not quite a doxing storm. There was one time there was a thunderstorm, like, oh, look at that, there's a big thunderstorm approaching. And it was literally like over my house, and that was it. All right, so that's just warm. Yeah, we gotta fix this encoder. Otherwise this thing will eat itself. I think it's over here that the problem is. Let's take a look. These are hard to probe. I don't think my pins go into these. Oh, they do. All right. Well, maybe we should ohm it out just to be nice. I don't remember what my pinout was. I wrote it down somewhere. I think it's in like an image somewhere. But yeah. All right. We'll ohm it. We'll be nice before I start ripping apart connectors. Because these industrial connectors are really cool. They're very well put together. But I gotta make sure that all my stuff works. All right, so we are going from, well, let's go through the whole system all the way down to this connector here. Although LIN bus will be only on this one, but I'm putting it all through the same connector. It's the encoder and LIN bus, so. It's just, ugh, God, everything is tangled. Everything's tangled. Everything's tangled. It takes two to tangle. All right, let's see. So, starting with, and I have no idea what's connected where. One of the LIN bus pins. We know LIN bus works, sort of. I don't know. Maybe it doesn't get all the way out to here. Actually, that would make sense for why we don't see the shifter. All right, that works. Get 2 ohms on that one. You know, maybe something ripped off in here, and that's why the shifter doesn't work either. Yeah, I'm taking this apart. I'm taking this apart. If the shifter doesn't work, that means that something's not getting all the way out to the the remote LIN bus stuff. That may be what the problem is. It's not what the problem is digitally with our buttons not writing properly. I think the way that we get to that is that we plug the module back in, start this thing up. I don't know, and maybe put a serial sniffer on it? I don't know. See, I don't know what it should look like when those varying signals come through. All right, so I need a wrench. I need like an actual wrench to do that. What size is it? 13? No. I happen to have a 13 right there. Didn't work. What's up? You try to sell me stuff? All right, I got that. That's not a good wrench. Where are the good wrenches? What did I do with them? They're on the wall. There's one. That's too big. Where's my small? I have a like really tiny. Okay, here we go. I got this one. Wow, that's a strong fucking magnet. All right, I got this one. And I got, I think another one. I think there's another one, and it hangs out inside of the bins that are behind the soldering iron, or under the soldering iron. Under the soldering iron. There he is. Oh, it might be too small. Why am I hanging on to this thing? Ugh. Rusty old tool. I mean the fun kind. All right. Open it up, industrial stuff. Industrial stuff is always kind of interesting. The connectors that they use and everything they've always got something neat to show. This has been a process. I mean, it's like everything that could possibly have gone haywire has at this point. I think we're out of... This doesn't fit. You son of a bitch. You betrayed me for the last time. I know, yeah. I put it back in the... Listen, I'm not in any kind of shape to make that sort of game time decision. You kidding me? I don't trust me right now. Present day bother is not to be trusted. Past bother probably knew something. They probably had a little piece of information that I don't. And I'm not willing to bank on that one piece of information coming to fruition. So I hold on to stuff for 10,000 years. All right, I'm gonna get another. I got another monkey wrench. This one I put on the grinder in order to undo the ball joints on my car. For some reason, you need a special wrench. And the special part about the wrench is that I reduced the size. I reduced the cross section of the wrench. That was lefty loosey. It is. It is lefty loosey. All right. It's just a weird kind of a thing that like grips it. Okay. We can sort of sneak that back. Sneak this back. Check all the statuses of these. They look fine. Yeah, none of them have really tweaked. One of them looks a little bit badly soldered, but I'm not willing to... Well, actually... I mean, it's on there. So really, it's not a good showing. So I can fix that one. Otherwise, these look like they're in decent shape. Yeah, I'm not really seeing any issue. Except for that one. Except for the blue one. Oh, it broke off. Well, there's your problem. Okay, so this one needs to be resoldered, and I think that's it. Just the blue wire that's sort of hanging out in the wrong part. It just wasn't soldered in. Let's get it soldered in. This is probably going to hurt me. But it looked like it was making a perfectly fine electrical connection. Oh boy. That was a little toasty. Alright, that's on there now. As far as encoder pins go, let's see, ooh, a little bit of drama there. Let's take a look at this like really close up. I think we need to take a real close look at this. Make sure that nothing is in bad shape here. I mean, my best guess for what's going on would be that something was wrong with this cable, but I'm just not seeing it. Man, there's not a lot of real estate left on the microscope anymore, huh? It's so much shit on screen at once. Probably have to... I probably do one of these here. People have big monitors nowadays, right? Where's that one? Hold on. Hey, RYG. Why is OBS like this? Why are you like this, OBS? Go, and then you guys, this one, this. Hello? It doesn't let you move stuff unless you click it. It's not letting me. There. I have so much stuff that's on top of itself. And then like that. And then hit this. One of these. And where is it? Which one of you? Okay. From like over there, you need to be moved. Yeah, this whole thing. I should treat this as one, but they're separated from one another. You guys actually need to be a little smaller, like that. Sorry, just doing a little late game rearranging here to get things right. They're going to be off by like a couple pixels. Yeah, that's good enough. All right, that gives me plenty of area to work. That's the point, is I need to be able to see what I'm actually trying to look at on this camera, so. All right, now. What is that going on there? Oh God, it's worse than I thought. Look at that orange wire. Game over. All right, so orange wire needs help. Desperately needs help. I need to get more consistent light over here. This might be the problem, is that the orange wire is kaput. It is done. Pretty much hanging by a thread, the very definition of. How are you doing, white wire? White wire does not appear to be doing much better either. It's not really that it's, yeah, I mean, a little bit. It's warm in the enclosure, and I don't know, it just does this. That's just how it gets. Yeah, I think it's because of latent heat inside of the enclosure. Yeah, it's the same problem that we had before. Yeah, orange and white need to be, they need to be worked on a little bit here. Yeah, there was like almost nothing holding that in. I need to back all this stuff off so I can actually work on it. Problem is, orange and white are right next to each other, so trying to extend these in any way, shape, or form is going to be very difficult to do. The white wire looks kind of salvageable. Let me see if I can get as much of the white wire out of there as I can. Come on, bud. There we go. All right. The movement of this microscope is bothering me. Hold on one sec. It's like streaky. Properties, configure video, FPS 30, click OK. Notice how everything changed. Properties, configure video, blah, blah, blah. Let's go to the FPS and turn it back all the way up. FPS to highest. And then we go to setup the microscope camera. That one. Video flashes, everything goes crazy. Oh, it's so much better. I can manually open the aperture a little bit. I can go back to that one. There we go. Now my video actually has FPS, believe it or not. Yeah, so the orange wire was coming undone. That's probably part of the problem. And the white wire is in real shit shape. But it appears to all still be there. I'm going to tin these. I'll try to reattach them. Remaking this cable would be a major pain in my ass, so hopefully we can just do a little on-site repair, and then I can actually wrench down the bolts on this thing, and it'll be stable again. I need like I'm going to clamp some forceps to the part of this cable to hold it together. The forceps might damage the cable. Maybe my weaker forceps? Maybe if I just put them on the other side of the forcep? Nah. Regular forceps. There. Weak forcep clamp just to keep everything stable, although I will want to be able to pull on these wires a little bit more. I think the wire pairs that I used in here are from a DVI cable. I took apart a DVI cable and I had a bunch of wire pairs that were all twisted like they should be for the differential signals and stuff. This is a much better view than what we normally have. I like this a lot. I think this will work out. Okay, careful, careful. I just want to make sure that the wire, the solder gets up there a little bit so that the flex point is a little bit further up. If we're lucky, it'll have a little bit of the jacket as part of it. And I don't want to squish it with the tweezers when I solder it back in. That's the only problem here, is that I'm going to unintentionally, you know, squish the ever-loving crap out of this thing, and it's not gonna, it'll like sever the wire. Not sever the wire, sever the jacket of the wire. Damn it. Be careful with my precious encoder data cable. This cable came as a kit. I think it was like $20 or $30. It was $30 at the time. It's like an industrial motor cable repair kit with the Mitsubishi plug on the end. Oh, uh-oh. Okay, that was a silicon jacketed wire. I was like poking something with the iron. You get perspective on that. Okay, yeah, that's good. What's up, Turbo Nad? How you doing? We're getting there. It's slow progress, so we keep running into little issues. That's right, you rated earlier. Terp. Good Distant Cacophony also rated too. That was great. That was great. Slow baby step progress is what we're making today. Flying helicopters. That's great. I bought this cool toy that's like a helicopter and a ball, and you just throw it against the wall and stuff. I give it to my nephew. All right, that might solve our problems. Every single problem that we've ever had is now gone because we did that. All of our problems just melt away. Yeah, just as long as I don't twist this thing too much. So I need to make sure that this thing is actually seated now. Make sure that this thing doesn't come undone. Because if I screw it in versus this piece here, it's going to twist those leads, and that's the last thing that I want to have happen. So I need to make sure to really lock this fucker down. All the flexing should happen here, not here. I guess this is where my very thin wrench comes into play. Almost like I made this so many years ago. No, I made this for ball joints. I did not make this for this cable. Oh, what the fuck was that? Okay, super tight. That click over, I think is what I needed. I think that's what I needed. I didn't do that before and it kept loosening itself. I think that's what these little ridges are all about. Swedish nut roundener. Yeah. Yeah. All right, try to tighten this without twisting them. I really hope that doesn't twist them when I tighten it, but there we go. So that hopefully will fix all the problems that we just had. What the Did people hurt their fingers using these? Yay. That's an achievement. You know, obviously I should have the right size wrench for these things, and I probably do. It's too lazy to find it. All right, there, nice and tight. Now, theoretically, I'll never have to open this thing up again. Ha! As if. As if. Ooh, don't poke the leather of the steering wheel with a wrench, you idiot. Fuck. I'm gonna put a permanent mark on my leather. My beautiful steering wheel leather. Okay, back out a little bit here. Give me some space. Give me some space. Okay, so we had two lines that were kind of a problem. We soldered them back in. Let's see if that fixes the weirdness that we had with the encoder. Because, you know, it felt like an encoder problem. It felt like either a force feedback was reversed problem or an encoder problem. Put all my toys away because they're projectiles. Yeah, that's true. They're probably not metric. Although this would be Mitsubishi sized, so the LP10S. Really cool cable because it's got this little locking mechanism. I actually really like this. It feels cool to use, even though technically in an industrial scenario, you'd plug it in once and that's it. All right, I really hope this works and I don't have to undo all this stuff again. Try it. Sure, that's plugged in. It looks like it's crushed. Weird. Please don't jiggle. Please. Please. God damn it. That wasn't it. Why is it doing this? Why? That's a really weird problem. I don't know. I don't know how much percolate I can summon in order to hold on. Let's go to the That's not it. No link. Bump stop, steering. Nobody's fixed it. Direct input simucube, hands off craziness. There's a lot of problems with this kind of thing. It feels like the encoder's bad though, because it fights and then it goes clunk over to the next piece. And it might just be a matter of, I don't know if I need to like recalibrate it or something. It really shouldn't need all of that, but I mean, I guess we could try. What I really need to do, let's open the Ioni Cube stuff. Let's open oh no, but I'm not plugged into it. Wait a minute, I can't do that. Never mind. Software, simucube. We have to plug in USB to the other plug, which I could do, but first, I don't want to totally... Well, I guess maybe restarting simucube might help. See what happens. I don't like it jerking around the way it's been. There it goes. Why are you doing that? Maybe reload settings from simucube? I don't think that's doing anything. Init success. Nah, it's still messed up. Unplug and replug? Maybe. I mean, we fixed a couple things inside of that cable. Could be stuff in that end and the other end of the cable. I know my spring is loose on that one. Like if it doesn't have all three phases, maybe it's kind of lumping over from one thing to the next. I use existing or constant below. Indexing your wheel. Yeah, that should be fine. I don't like this. Please center the wheel. Whoa, that was really weird. It was like fighting me back and forth on that. Motor's initializing. Take a minute. It always does like 90 degrees from where I originally positioned it for its okay, press next. Steering wheel center point. Please center as accurately as possible. As I move it back and forth, I can feel weird interactions though. I don't know what's going on there. Okay, I'm gonna have to keep a hand on it. Next. Don't lock any fingers into the pawls of the wheel. Finish. I think a phase is missing. Cause see that? It's like clunk clunk right there. Did I have a phase break off? Well, now it's not doing any bump stops. Yeah, all my center position and stuff has just been lost. But it's fighting me a little less, but it's still... Yeah, is the tracking okay? Looks like it is. So it's a motor thing. All right, we got to open up the motor connector. I'll have to reprogram the bump stops and stuff. Look at all the power this thing is ready to fucking pop. All right, let's take a look at the motor power connector. This is the one that's most suspicious right here. This is a directional plug-in, so they shouldn't have been plugged in backwards, but you can see here that my jacketing is starting to kind of like peel back a little bit. This is the harder one to get into, too. All right, so let's take a look here. Phillips head. All the plugging and unplugging has finally gotten to it, I guess, and some of the slightly less robust pieces of the design are starting to fray at the edges, which happens over time with things like this. I don't know what I expected. These are perfect. I don't know what I expected. Give them a tug. Nothing. They're fine. Why are you acting a fool? I mean, so from what we saw from the encoding, everything looked okay. From what we see from this, everything looks okay. Unless I ohm it out and magically one of the phases is gone, and it's the only other option that I have is to measure them now. The motor's nice and warm from all the power that's gone into this thing. Why would it all be fucked up now, though? That doesn't make any sense. We fixed a dodgy connection or two on the digital connector, but, like, this stuff is good. Everything inside of this is perfect. Supposedly. Theoretically. In theory it is. In theory it is. Alright, let's see. Turn this thing on. Let's get them up on ohms. Yeah, I don't think it's a broken wire inside of that thing. The thing is, like, so strong. Like, I need a way to flex it while I do this. Flex it out. Fine. That would be this one. Yeah. That one shouldn't really matter all that much. Opposite phase. Huh? Hold on. It might just be me. It is just me. These are slippery connections. These are slippery connections, as they are. Damn it. Fucking just... Okay. I don't like that. Is that me? That was just me. That one's fine. And then this one's probably going to be just the same. All the same. It's all the same. Nothing's wrong, but everything's wrong. Nothing works. Excuse me? Wait a minute. Yeah. Yeah, it's all fine. Everything is fine. Everything works. Hey now. Oh, man. This is frustrating. One step forward, two steps back. That's what they say. Getting so much booty, I don't know how to act. All right. I'm going to try to seat this properly this time. Get all this stuff in here like this. And where was that supposed to go? I think that's on the other housing, isn't it? I have a little bend in the front of this thing so that it goes like that. There we go. And then this on top of it, I need to, like, get more of this in there. It feels a lot like it's when the wheel isn't recognized properly by, like, a simulator, and you just need to, like, reverse the direction, and then everything starts working. That's what it feels like, but I don't know why it would come up suddenly. Especially like that. You know, and then drop this thing like that. Let me get this back together before we continue. And it happened after I took that board off and put it back on. Yeah, I guess I could look at the differential pairs. I can clip into that. Ah, shit, I didn't get these back in. Well, we don't need them right now. Put them over here. Well, if I'm going to do it, I'm going to do it right. Damn it. Fucking thing. Can I get one of them in? Yeah. I don't want to have to rearrange all this stuff so that it fits in again. All right, let's do that, and then that. One over here. Come on. Come on. Stupid. Ah. Got stuck. Get unstuck. Stupid little bat. All right. Everything is always just fighting me right now. All right, and then I can loosen the other side. And I can get the other one in without unseating everybody, please. Hands are starting to turn into claws. You can hear the PWM of your Corsair keyboard. Oh no. What is it like getting into the like a speaker line? It's always a pain in the butt, huh? Fuck. Please, I just need. No, it's like getting stuck in a weird spot. Please. Work with me. Please just work with me. Please. Why is it being a jerk? There's like a ridge that I needed to like pop past. Oh, and these are flathead, of course. The most frustrating of all the screw types. Flathead. Just need like a millimeter. I gotta rest my thumb muscle for some reason. God, like it's just gone. It's just gone. No more muscles. There you go. Now lock it in. Don't let it out. All right, so that's a really solid connection. I mean, these metal housings for the DB connections are like super duper good. The other thing that I could think of, I mean, we were seeing encoding coming through properly. I would investigate the other end of this guy right here. But again, you know, everything looked pretty nice on the inset there. I don't know why unplugging it and plugging back in this other piece would have any effect on it, aside from if I somehow unseated the card, which is just perfectly in there. Try to push it down a little bit on the other end. No, it's in there. Aside from like brushing up against some of these here, maybe I severed some of the encoder connections. They all really seem to be in there though. I mean, the encoder seemed perfectly fine. It seemed to just enjoy life. It was so full of life and just living its best. Doing everything it can, you know? I don't know. I mean, maybe something just lost its codes somewhere. You know, it may have seemed to have come back to life, but it certainly didn't do anything differently from before. It was just as fucked up as when the wheel bouncing back and forth was just as messed up as before. I don't know if that means that maybe the IoniCube card somehow reprogrammed itself. I don't think that's the case. And I do have backup files for that one. That's a really good connection. Like, nothing can interrupt that one. Turn it on again and see what happens. It's going to give me a little go-ahead. Beep, boop, beep. Wait, are you back? It's back. It's back, baby. Wait a minute. Let's recenter you. Okay. It might have been the stuff that we were just playing with then. It might have been the three-phase connector. The big one. Just resettling all that stuff. Yeah, intermittent faults. My favorite. Oops, I clicked on something. What did I do? Oh, wow. It is way off. Oh, no, there it is. We just didn't have it. I didn't have it focused. Oh, there's a partial disconnect. Ooh, that almost led to disaster. Yeah, that must have been a one-phase disconnection. Wow, this thing is, like, fighting like hell. There's the end stop. Whew. I had it set to feel like driving a real car, so... Yeah, it's a little better. Feels a little bit more like it's faking it. Okay, well, that was a weird intermittent connection issue. We still have button issues, though. If I push buttons, they push and they unpush. They push me, and they unpush me. Why do they do that? This would be right and left. So the right and left button. But we've looked at all of our serial printouts, right? This is frustrating because we've looked at all of our serial printouts on this thing, and they're super duper stable. They're super duper stable. So what's happening here? I wonder if we're getting any of the shifter, actually. Wait, hold on. No. I have to set initial conditions, by the way, for some of the... That's why those 3 buttons are hit. I didn't set initial conditions properly. And also, maybe some of these are plugged in backwards. Yeah, that might be it. Yeah, so our shifter still isn't communicating properly. God, that thing's clunky to use. It'll feel more comfortable when you're actually, like, driving something. All right, so we pretty haphazardly inserted all this stuff in here. The ones that are stable, I mean, right, what is it, right and left? So if I hit, left, right, up, stable, down, stable. Phone, unstable. It seems to be interacting with the buttons around it. Speak. I'm going to make notes of these buttons because I think maybe they're encoder inputs. So we had right, left, phone, or like, yeah, telephone. Right, telephone. Yeah, only if I like tap it. Speak. Plus. Plus toggled on. Plus, I think what it's expecting is an encoder. I think that might be what's going on. I don't know how to make it not an encoder. Mute. Minus is also fucked. Plus mute minus. Okay. Yep, okay, it's having problems. This feels like encoders are all screwed up. Right is having problems. Back is having problems. What the fuck? That's like almost every button. Oh, up is still having problems. Oh, that's great. No, we've already looked at the digital printouts, and they're as stable as they can be. And then the pedals, or the Whoa, what the fuck? Why are these unstable now? Look at that. My only fear is that we need to use the packet scheduler in order to not interfere with stuff going on. But when we look at our actual, like, packets that are running through... Oh, serial's not available. Oh, yeah, it's not plugged in. Okay. Is it going to get more stable when I plug it in? Well, I also don't have the program focused. I wonder... No, see, it's not, it's like it's not registering stuff properly. Like, those little breaks that you see are it saying, my butt, because stuff's happening in the butt. When it says my butt, what it does is it transmits a button press packet. And it's pretty goddamn accurate to the way that this thing should be working. Only that the endian is flipped. Well, the talk button seems to not do anything. Talk button isn't doing anything. It might be in a different part of the packet, I don't know. Aside from that, I mean, we've got really stable response from everything. So what could be happening here? Oh, look at that. Nothing changes? Wait. What's going on there? Wait, it's registering a change on the up button. I think maybe we're not printing everybody out. Yeah, there might be a couple that are locked. It's so stable and yet it's not working, huh? If Surmon is seeing it, is it stopping the other thing receiving? No. It's a different serial port. They work independently of one another. So it's literally, I mean, the serial prints are fine. This is where we're just bashing it into the right locations. I could have it print out what the packet looks like, what it's actually printing out. Is that a, I don't know if I have that locked into a, I just have verbose. Low energy output print is going to be a mess, but I can enable it. It's funny because when I do the button test, it was like perfectly accurate. It's just when I actually hook it up to the LIN bus stuff, everything seems stable all the way up until... Let's just try this and see what it looks like. Let's see what happens to us. I wonder if I lost the ground connection. That's why I was going all crazy. We were supposed to be gaming today. But no. We're stuck here looking at cereal packets. Like as if we have a decoder ring. So we're going to get a lot of mess until this thing finally registers itself. There it is. And now we have, in conjunction with the buttons, we have the packets. So if I hit a button, we're going to see the packet. So I'm going to hit a button and then undo auto scroll. These are the problematic buttons. Okay, there. So, all right. So what do we get when we push the button? We should get my butt. And then it'll send the button change. Well, it didn't say my butt. I guess I got rid of my butt. Why is that sending as a 4-4? Why is it sending as 4? Okay, all right. Let's dissect that. Let me just get these into the notepad. I pushed a bunch of stuff, so that one. Ah! Where did it go? And then when I release the button, oh, where are these coming from? Push the button. Nothing happened. 7E0, what's going on there? I think maybe I'm not printing out enough digits. Take that one, and we'll take the next one where I release it. Take that one. Okay, so I'm gonna turn that off, and then we'll take a look. Let's dissect what we got here. This is the special that I've been doing over the past couple weeks. Delete, 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 delete. Da 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 da. Okay. 4, 1, 2, 3, 4. We'll just split. Oops. No, that's not what I was trying to do. Doot, doot. 4, 4, 2, 4, 4. There we go. So, why? 1, 2, 3. I'm not printing out the. Am I messing it out? Yeah, we're not printing out the whole thing. That's why I'm not seeing stuff happen and stuff magically happens, right? So we have a change here, and because it's little endian, these get flipped. So this shouldn't be completely flipped. Why would it become a 4 then? Because that's a 3. Is something happening where my packet is getting misinterpreted? Well, that may be the case. Well, for anything after the 4, right? It's these 3 right here that we're worried about. And then we have the F0, which is here. So whatever's in here ends up at the top. And because we're missing... Wait, but why would that end up being... Well, that would be a 0 then in that case. And that makes it 0, 4 for the last piece of that. So that packet makes sense. Let me get to this one, and things go crazy. Oh, okay. So that's not a change. That's not a button change. There's the button change. This is in fact what do you call it? This is an RSSI, right? Does it really look like that with the zeros leading at the back? RSSI might be cursed. What does an RSSI packet look like? All the way down here. Let's look at an RSSI. I think if that's messed up, we need to fix it. Zeroed button packet, characteristic notification, get RSSI. That's a different one. That's the one that we send in line. Is that what we're sending? No, we're sending the notification for RSSI. Where is that one? Did I store it in this document? I don't know if I have it. It's 21 and 1A. So this one's 99115. That's another 15. This one's another 15, 17s. Then we got the 11, which is the button presses, and the 1A. Yeah, I didn't write down what it looks like. I have it in another document. Mercwheel. And then maybe... Oh, that's a different one. Open. I've taken 120 fixing a switch once or twice, and I don't care for it. I don't ever want to do that again. It feels really, really bad. All right, way down here. Get RSSI, button press, get RSSI. Where is that command? The characteristic notification RSSI. That's a button press. Button press. This is where we get to check over like literally everything, huh? No, this isn't the right document. I need to find the document where I talk about that stuff. Open. Let's see here. New packet procedure, motor parameters, module connect, granite wireless packet dot text. Here we go. Let's see. I'm looking for 1A. So it should look like that. Close enough. Yeah, that's right. Okay. Good. Good. Our RSSIs look right. Our batteries probably look right too. Although they are coming in pretty often. But when we release the button, we send a separate packet that tells us that we've released the button. So is it, I think it thinks it's an encoder. And I don't know how to tell it that it's not. But then again, the like shoulder buttons are also having trouble with that. And why did that change? Okay, so that's 21. Okay, and then this is the keep alive signal. Okay, so far, I'm not finding any problems with the way that this thing is operating. From looking at the button register in relation to the packets that we're sending out, I'm not seeing any problems. It's just not working. It's a little disappointing. So it might be down to the simucube software for not treating it properly. I'm going to turn this thing back on and we'll take a look. Oops, maybe I should open up Serial just so we have a readout. But I don't know if there's like a setting that I'm not doing. In like the wireless wheel, I don't think I can specify whether or not it's an encoder or not. Well, let's flip it back on, see what we can do. At least now I'm not missing a phase of the motor, so everything's reacting properly. Yeah, this will have to be disabled in a minute. Okay, there's all that stuff. Got that running. That's all well and good. We go over to our software. I look at wireless wheels. Can I look at any other properties of this thing? It is connected. Nope. Profiles. Nothing to do with the buttons there. The hardware setup. Motor encoder center point. Configure X12 button inputs. That's X12 upper and lower. That's not, and then I've had it report the buttons for the wireless wheels first. Is there something else that I need to do in order to make sure that it's not being treated like an encoder? That's all I can really think of. Yeah, nothing else in here. Man, that is frustrating. It shouldn't need to keep telling it that the button is pressed. Yeah, see, like, I hold that button down and it stays down. And I let go and it undoes. Hold it down, stays down. Let go, undoes. Press one of these, boop, boop, it's gone. Gone as soon as it comes in. And yet, in my settings over here, we won't really be able to see it fly by, but I press it and it changes, and I let go and it changes back. Here, let's slow down our prints a little bit here. Let's slow this down a little bit. Turn that off. What I need to have happen is when I do the low energy, we'll keep that, print the lin packets, but instead of printing button 1 every time, we need to do it on a change. So our print is down here, over here with the print buttons. And instead of printing here, copy, I'll take the whole thing and I'll disable the whole thing from right here. And I'll put the whole thing into the button checker into our butt checker. And instead of saying my butt, it can say that the module status has changed. Where's my butt? Somebody find my butt or I'm going to get very angry. Where'd my butt go? Where's my butt? There it is. There's my butt. I found my butt. Actually, yeah, send button packet handle 1, event, buttons old, verbose print, send button packet of H. What I'm do, put that print right there. Put that print right there. And what that'll do is that'll now enable us to only see when the buttons have been pressed. Let's upload that. Thank you guys for the follows. I don't really announce follows because I'm introverted. So I don't like all the fanfare. Streamer starts crying and like personally thanking you for following them, and I can't do it. I can't do it. All right, turn that on. I'm really hoping that we find something like fundamentally wrong with this program, because from what I understand, the way that this thing pushes buttons is that it sends one singular packet out. So this is just keep alive. When I push a button, there it goes. Motherfucker. That is just about as stable as I could possibly ever consider it. And yet it's unpressing my buttons. Something's going on here. This isn't me. I may need to like observe the thing running again and see what's happening. The simucube wireless button plate configuration tool, but this thing should work as just like a button input, not an encoder input. I mean, I know that tool exists, but the way that the racing company that I bought this thing from seems to frame it is that it's just like for buttons, for button inputs. If they have it configured for encoders, we might have a little trouble, and we may need to explore what some of these mean, what some of these registers are. Maybe if we send it something other than F at the beginning of the thing. Or maybe there are just positions on it that we don't know about. But I think what I can do is plug in the other module and see if it behaves in this manner. And if it doesn't, then we got something to check out. We're very close. We're very close to getting this thing running. Damn it. This is going to be another couple days of me poking around inside of this thing. We're so close. You know, we're pretty much like there. We pretty much have this thing running. It's just that for some reason, part of this thing is not speaking correctly. And it might be that it's supposed to be an encoder, but I doubt it. But it does seem like it's out of our control, because we're not, you know, when I press the button here, see that? We don't have any erroneous packets running around in here. It just immediately sends the thing or the other thing. Yeah, and I should be able to just hammer away at it. There's a little bit of lag on it. I mean, some of them were running very quickly, but... Two paddle inputs, 4 encoders, each with A-B inputs. But these are specifically showing up as buttons, though. That's the thing. Misconfigured pull-up. No, look, we're... Guys, I don't... Everybody defaults to hardware. It's not a hardware thing. Look, We have everything running and flowing and working perfectly. All the digital communication is happening. And when I push a button, we get a packet generation. One packet generation event, not two. When I release the button, we get one packet generation event, not two. But if I push the button, it presses and unpresses really quickly. And then I release, and then the next one down the line presses and unpresses. It feels like it thinks it should be an encoder. Which is odd to me because the encoder should be like working in kind of a sequential manner, right? Should be like locking down on stuff. Strange. But yeah, I'm baffled as to how to configure this thing to be all button inputs. I'll have to take a look. I gotta take a look at what the place that sold me the button plate has the thing configured as. And I think we're still not printing out the whole thing. I need to fix that. Hold on. Not printing out the whole thing. So where are we printing it? Print buttons 1. That's this function down here. I mean, oh, wait, what's this? $31 greater than or equal to 0. I minus minus. That should do it, right? Because it's a 32-bit number. Maybe it just wasn't coming through properly from that other thing. Let's try again. That minus 0 was probably affecting it poorly. I don't know why it allowed that. Oh, we need to restart the whole thing. This is just a bunch of like weirdo serial data that it uses to get everybody ready to go. And then now it's registered and it's just hanging out, and we push a button. And if I hit this one, yeah, the call button does nothing. That's weird. Other one. Yeah, it's not printing the whole number, is it? Oh no, there's the one that's changing. A lot of data flying by all at once. Well, I'm a little bit baffled. I don't know what's going on here. Whether or not there's something I could do to the signal that's coming through to register it properly. And it's slow. It's a little bit slow recognizing the button. Even though I am instantly putting the packet through. Well, it seems like on the second press it's a little faster. What if I focus the window? Press release, press release, press release, press release. Yeah, it's off. It's off by a little. I mean, I guess maybe my button presses should be really deliberate. That one sticks. That one sticks. I mean, if I want it to register button presses, some of them double press buttons though. That's the only problem. Is that like I could almost forgive the press and release methods that this thing is putting into place if it would get the button right. But like here, I hold down a button. I pressed the button and it went back and forth. I think it does think that it's an encoder. I wonder what we can do about that. Because I didn't think that if we are using this as if it's an encoder, what is that? How do we change that? Well, I think those are questions for another day. It's getting on in hours here, and I'm starting to get hungry, so I'm getting hungry. I kind of want to get a hoagie and wallow in my unsuccessful attempts here. I do not know why this thing. Well, okay, so the next step is pretty clear. I need to plug in the module, and I need to let's go to a normal cam. We learned a lot today. We learned a lot today about how things fail and nothing ever works, and everything we've ever tried is unsuccessful, and all of my ideas crash and burn like an airplane without an engine. No, I need to plug back in the circuit board that's over there, the little circuit board that has the stuff on it. I may need to put together something that's going to scan the button packets. and only print out the button packets, because that way I can observe what this looks like. Yeah, because the proprietary hardware for some reason wasn't doing it with lag. It didn't have any interrupts, but all I do is check to see that the button registers change. Like, everything I'm doing is very quick. So I don't understand why I would have lag in my system, you know? I mean, maybe I can slow down some of the reporting of like the button and the battery in the RSSI, but I don't understand why the response to the buttons being pressed isn't faster. And if it is going to be an encoder input, how does that work? How do I hold it at an encoder? I might have to fake being an encoder, or I can figure out some other piece of the puzzle that's going to make it into like a button plate and not, because it's 16 buttons per device. Like, that's stupid. I'm not going to do that. I would need to then register 2 modules just to use their button inputs. It might be that the shifter inputs are earlier in the stack, and they might actually come through perfectly fine. I mean, the whole point of this thing was so that I could use all of my steering wheel buttons. And it turns out I can't. Not until I understand a little bit more of what's going on the signal. And obviously, Granite Devices isn't going to tell us. They'd rather I just buy more modules. So, but that's not how my system's implemented. So we got to figure this out. I don't know if we can play with the F0 at the end, because that would be 4 more inputs. But the ones I'm having trouble with a majority of the buttons, and they're unpressing themselves, which is weird to say the least. I think we need to play with the other module and see if it behaves in the same manner as this one. It might be that it does. It might be that this other module is registered to have encoders in it, and maybe that's a difference in what that packet looks like. Maybe the 11 packet has some slight variation in it. I don't know. There's not much like other room in it, right? Hold on, wait. Let's just quickly look this up. I want to quickly look this up. Where is it specified what does what? This is the wireless wheel number 1. Going into the module and coming out, it's just TX and RX. Sim wheels, blah blah blah. Upgraded version. Wheel 2. The wheel 2 is not available from anywhere. Why would you do that? So button and encoder. Integrate the button plate wireless module into design simply by plugging the module into the PCB connector board, configure the module, blah, blah, blah. Customers connect wireless button plate to the simucube devices, pressing both paddle shifters simultaneously. It needs an add-on receiver board. 28 input devices wirelessly to simucube force feedback controller. Button inputs and encoders in 111214 mode are supported. Incredibly low energy. Datasheet is available. Let's just open that up. Factory default connector for input is stored on the device exactly as on the datasheet. Factory default pins marked as buttons are buttons and encoders as encoders. The button plate module is advertised itself as unnamed button plate. Input modes and encoders types can be changed only on the button plate manufacturer and resellers via a separate hardware programming device. So if they're giving it to me default, it's not going to have that configured, huh? Default mode for encoders is 1 pin state change per detent. It's not possible without programming the device and software that's available. Okay. Configuring is not supported for DIY purposes. Yeah, go fuck yourself. You go fuck yourself. Blah, 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 blah. Okay. Okay. BP, huh? Can I name it BP and maybe it'll... I don't think it's down to the name. Push comes to shove, I can do 2 16-button wheel things, and we can avoid the encoder inputs. Yeah. That's push come to shove. That may be what I need to do. But then another question is, what can I do to that packet in order to make it into a button plate as opposed to just a simucube thing? I mean, the name of the device doesn't really come up on anything. That might be down to the MAC address. What is it? What it had a picture of like the, yeah. Okay, it doesn't look like that changes. TD2, TD1, and BP. Ours came up as, well, I don't see, I don't, it's like unknown, I think is what the name came up as, right? So I don't know where that information would be. Scanning. MAC address can be used to identify different wheels. Names are set by wheel manufacturers, and therefore, e.g., all wheels of the same model may have the same name. On the other hand, MAC addresses are unique, can always be used for identifying. Okay. I wonder. So 2 possibilities. I can have 2 devices come up on the network, and then we can use the known good 16 buttons. No. Listen, I have complete knowledge of how this works. I have one of the button modules. It's nothing. The only possibility is that some of these registers are slightly different that I use in order to register the module and have it come up onto the simucube. There's all kinds of information in there, and so one of the pieces of information might just detail the difference between an encoder and a button module. Now it's 32. It's 3 registers. 16 of those, half of those, 2.5 registers. And that's 2. No, half. So it wouldn't just steamroll the F0 then in order to press buttons. I gotta think about that. This is a weird one. This is a weird one. I wonder if it's just C, right? If that last piece of the packet is just C, if we just undo one of the 1-0s, maybe it puts it into a different mode where it'll recognize the buttons differently. That's something that would be relatively easy for us to test. It's unfortunate they don't give you any more information about this kind of thing, though. They're simply like, they're just like, don't worry about it. Yeah, here's the pinouts. Any other pins? The wireless button plate logic monitor has 28 pins for input devices. The first 2 pins are fixed and must be connected to the paddle shift. This is for their hardware. Mine doesn't adhere to this. Well, you could roll back to some of the earlier versions of OpenWheel. That's how you would do open source. Push buttons, different purposes, the other pins. So that would be 1, 2, and then off limits, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. So that's 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's It's odd that it doesn't like. I wonder if I follow the logic, if it'll. It does seem to kind of follow encoder logic, doesn't it? And then I wonder if shift. I don't think any of the buttons are registered as a shift button. Wireless button plate supports encoders of 1, 2, or 4 state changes per intent. Wireless button plate modules, part of a sim wheel. Okay. So it might be that in order to get by this problem, we may need to just register 2 modules. And that way I have all of the buttons available to me. So like it'll be shifter and some of the steering wheel, and then it'll be, the rest of the steering wheel buttons. It's just the way it's got to be. That means that, well, that's not too much of a departure. It's just that the button 1 register is going to have to be split between two prints, 2 potential printouts, and I'm gonna have to fully realize the module 1, module 2 progression. Ah, that's really annoying. All right, well, that's more shit that I got to deal with. We know what to do. It's not, there's a bit of programming work to do for me to do 2 modules. Alternatively, we can also play around. I'll do this Sunday and Monday. Play around sending it stuff. Sending it, you know, oh, what if I change that F to a C? What happens then? Or what if I change it to like E? Does it unregister the 2 modules? I mean, there's an F that's 4 bytes. I've got only a couple modes that this could possibly alternatively be in. And it could be down to the packet that it sends. And they just say, you have to buy the thing in order to properly program this module. Properly programming the module might just send a slightly different serial address. It might be down to something that simple. I don't know. But until I know the answers to these questions, I will be pooping around on the internet. You guys can find me in my Discord if you want. We didn't do a gaming stream today because things didn't fall into place exactly as I wanted them to. And that seems to be sort of the modus operandi of this fucking project. So irregardless, I hate that word, so I use it constantly. Regardless of whether or not I get this thing working, regardless of whether or not I get any of that special serial packet stuff running, it takes a long time for me to explain exactly what's going on here, and I hate to just steamroll all of your ideas, but I feel like I know what's going on, and I feel like I've got a couple things that I can poke at and see. Angry Wayne Gretzky is a great Twitch name. Got that Gretzky hair. I can poke at a couple things and see if it stirs. If none of that works, we can register 2 modules. I didn't want to have to do that. I've got a bunch of code in place. Basically, everywhere I do something with module 1, I do it with module 2. It's got a whole separate set of variables that it works off of. So it'll come up, register the devices, and then we'll have a fixed amount of buttons that we can do per thing. So it'll be like the buttons 1 is actually module 1 and module 2. It's going to be weird. Or maybe I'll just turn buttons 1 into a 16-bit and we'll just shift it over into 2 different things so that if one gets a change, it sends 1 packet. If another gets changed, it gets another packet. That's just how it goes back and forth between the 2 things. Man, that is really annoying, but I guess it's just what we have to do. I'll need more timing registers and everything too. Son of a bitch. Wow, that's going to be weird. Okay, well, anyway, success. We've made a lot of different successes today, right? We know why stuff is happening. We know what's wrong. We know some like little tricks and issues. We just need to, basically every single wrinkle that we could ever find, we found, and we need to iron them all out. So on Tuesday, hopefully I will have a lot of progress for you because I want to finish this project, get it running as best we can, and then play a game with it for a little bit. Then we got work to do on other stuff around here too. So I will catch you guys later. I hope you guys have a good weekend. I'll be on Discord. If I've got anything particularly visually interesting to share, I'll probably put it on Twitter. I don't use that a lot, but you know, when I do, oh boy, there's like 2 people that like the stuff that I put, you know, it's great. Hey, Adam, how you doing? Long time. Actually, not that long of a time. 14 months. Thank you for the 14 months. I appreciate that. Yeah, I'm just winding down because we've been pretty adamant about it today, and we've gotten a lot of stuff working, and we've kind of gotten to the bottom of a lot of stuff. But it looks like the discrepancy is that the default loadout for this device that I bought is a twisting encoder, which has an A and a B that does pulse, and so we don't know what to do, right? Well, we don't have encoders coming out of the steering wheel that I have, so we need to kind of strategize around that. And I'll test some stuff. I'll implement some stuff if I have to. We can get it working. We can do this. This is that last push. I can't even answer that question right now. All right, I'll catch you guys later. I don't think we're gonna raid. We might want to raid. I don't know. Who's doing right now? Jeez, everyone and their dog. No, you guys can figure out where you want to go. I mean, Davies is doing SnowRunner. Adam is just hanging out with the internet. Red Ultimus is doing Elden. Critical's Rocket League. Tomatoes does Spore. Oh god, that's cursed. Bruce is doing Fallout New Vegas. could be a fun one. Anyway, yeah, those are people that I just see immediately in front of me. Yeah, I can't help you with that. Anyway, I don't know. I need like a joke